meeting. For today's meeting and for note taking purposes. And I want to let everybody know that this is great. I have a problem. I'm standing room only. They're bringing more chairs. I apologize. My chair is available. If you want to come sit up here, you may not want to do that though. So I'm Kevin Hardy. I'm Executive Director of the National Water Research Institute. Really proud to be here today. We had a really productive first day yesterday. Spent a lot of time not only listening to important technical stuff, but we also spent a lot of time together learning about the infrastructure that supports what Southern California, where Southern California gets a lot of its water supply. So we talked about scale, we talked about audacity, and we talked about collaboration and consensus as a framework for solving some of the problems that we face in this world today. So I think the panel at dinner last night, we had a good conversation that reflected their understanding of the responsibility that the panel has today. And I'm really confident that we can produce an interim report that will help this project move forward. So next slide. I'm excited to talk a little bit about where we're going to go today. Here's the Wi-Fi access. Again, if you didn't log in yesterday, you didn't have to benefit. I'm going to give you a few minutes here. The password is like one of the hard ones, right? So it's capitals T, G, C, a second capital G, 307, and exclamation point. And you can look under the VIP Wi-Fi. Okay, next slide. Okay, so we've already recorded it, so we can keep going. Again, we talked a little bit about yesterday about the meeting guidelines. It's difficult in this kind of hybrid format. So I appreciate everybody's patience and appreciation for these ideas. Make sure that we've got complex stuff. Again, we did a great job yesterday giving the presenters everyone's attention. I appreciate that. So everybody in the room, great job. If you're online, remember to mute your mic unless you're talking, so you don't interrupt and you preserve bandwidth. And for everyone, we're going to continue to prioritize panelist questions. We've got some time built into the back end of the agenda so that we have questions that are associated with a particular presentation that haven't had time to answer. We'll be able to take some time to answer those. And we've also got some public comments. So next slide. Here's our independent review panel. Again, we introduced them yesterday, but Gordon, thank you for sharing great work yesterday. And I'm looking forward to bringing this report home. We have Neil Bonas from the University of Strathclyde. Appreciate you coming so far in the middle of the North American winter. So thanks. Faye Chai, thanks for I think Faye gets the award for coming the furthest. I think he gets that award. Online, we have Margie. Welcome back, Margie.
Glad to be here. Sorry, I can't be there in person.
Good to see you. Okay, good. We have also Alexander Kurapov from NOAA or NOAA. And finally, Mike Stugel from Florida State. So again, last night we had a great dinner and got a chance to get a sense of, how not only this community thinks about problems, but how we can begin to resolve some of the challenges that face us with this work. Next slide. The goals of the independent review, I'll lead here. Remember, we have three goals here. We want to assess the model's readiness and answer management questions. We got into a little bit about those specific management questions. We want to advise on model uncertainty. Okay, that's a big deal. What's the uncertainties associated with addressing the management questions that are in play, and then recommend next steps for improving model readiness. And I think that this sets the target for what the work is aimed at, and we want to make sure that we deliver on this as effectively as possible. Next slide. We have a busy agenda today, so I'm going to try to be done by just a couple of minutes here, so we can get into the technical matter. Technical section 3, we're going to talk about steps to quantify and resolve model uncertainty. We've got the modeling team. This is obviously a big issue, so I expect a good conversation on that. Then we're going to move into a technical input session from Andrew Lysing and the folks from the dischargers to talk about their sense of some of the ideas that might improve the model. Then we're going to take some time for a break, and then we're going to come back, and what we're going to do in technical section 5 is reserve time. We take time to answer the questions that we have gotten this far on. We've got at least 8 different questions. I assume that the modelers may have come up with a few more that they identified, and we may have come up with a few more today. So we got a little bit of work to answer some already curated questions in the elucidation section. We'll take some time for lunch. We'll come back. We have a public comment section, so that we have public comments in 2 forms today. One, for folks who are online, we'll go through some rules in a minute, but if you're here present, just let Tiana know during the course of the day you want to make a public comment. Just let her know that during the course of the day, and then we'll tee you up for noon. And if you're online, next slide. And if you're online, use the Q&A feature to submit your questions and enter the live comment. And you get two choices. You can either have me read it out loud, or you can say, give the comment yourself. Just let us know what you want to do in your email or in your comment and in the Q&A feature. And we will get back to you and make sure you know when you're up. So online people, be patient. We will try to get to everybody. I can't assure you we'll get to everybody, but yeah, I will do my very best to make sure that everyone who wants to make a public comment today will have a chance to do that. Next thing. Okay, so with that, I'm going to step back. See how we did here on time. Good. Got 5 minutes back in the schedule already. I said I'll take it off.
So, you all Jimmy Williams, he was on the January 9th webinar. And then also Karen McLaughlin, who I mentioned yesterday, was our regional monitoring coordinator, who's actually done a lot of the process studies that are, I think, in conversation. So we asked her to join us this morning as sort of backup support for the Q&A session following this. All right, so first of all, can you guys see? I shared my screen, so make sure that you can see it. Yeah, should I let you look? All right, Grace. Oh, awesome, Martin, thanks. All right, here you go, so. If you want me to put it for you. Yeah.
Yeah. Good morning, everyone. Again, nice meeting you all. So today I'm going to talk about model validation. Next slide, please. So how uncertain are our model findings is the main reason why the panel has been called to review our model. So what we have demonstrated yesterday, and also along the papers that we have published, is that the application of ROMS-BEC has the assets to support decisions on nutrient management, which in the Southern California Bight has $1 billion applications. So for that reasons, we understand that managers need clear communication about uncertainty to use it for decision support. So we want to understand what type of uncertainty we want to assess and what's the method we want to use. So we are here to help. Next slide. So validation is the exercise that will answer the questions about uncertainty. We started our webinar series by providing information about how we built the model and how we provided the tests and sensitivity analysis on key parameters of the model. Curtis Dutch also covered some of the validation at the byte-wide scale. That model has been used to force the boundary conditions for the smart scale model. That is the subject of my talk today. So here I'm going to go in the details about the method we have used to assess the performance assessment, to perform the performance assessment for the byte-focused configuration. So the goal of my talk today is first to summarize the approach that we have provided in the paper that I am providing in the slide. So this paper described all the methods we used for configuration and validation of the configuration in the Southern California Bight. And in my second part of the talk, I'm going to highlight ongoing work where we are updating our validation with more extended time series that goes over 20 years. And I'm also going to highlight some new data type that we have been using in the more recent period. So the performance assessment has features two major components. So the first one is what we call a qualitative synthesis, where we are going to test the model, how the model is behaving versus scientific consensus about ideas or published literature about the features in the byte, for example, in terms of circulation or in terms of biogeochemistry. And then the second component is quantitative, where we are going to perform assessment of model predictions versus observations for state and rates for physics, biogeochemistry, and plankton concentrations, and try to answer also the question about how the model is how the model is giving us the right answer for the right reason. So next slide, please. Okay, so I'm going to go through methods, but also I'm going to provide some examples. Here, what you are seeing, what I'm going to, I will start with ocean physics first. So I can hit the second, yeah. So my example here is very simple. For the qualitative synthesis, we are going to test the model to see first if it is producing the features that we know about the bike. For example, upwelling, constant circulation, recirculation around islands. Many of those questions that have been documented in the past in literature. So first, it's very visual. For example, here what I'm comparing is a map where I'm putting in black the average currents in summertime, and I'm also plotting observed data. So I'm comparing to make sure that the model is really representing the currents and intensity of the currents, the circulation or direction of the currents as we are expecting it to behave. Of course, we are doing it also for different features. I said again, upwelling, for example. In the right panel here, I am comparing one crossbar that is located here in our county area. Oh, sorry, in our Los Angeles area, just at Palos Verdes. And I'm comparing the range of variability of the current going from surface to deep ocean, up to 70 meters. So what we are seeing is that the model in black and observations in red are really showing the same average currents and also same variability of the currents. So it's very visual, very qualitative comparison. As first example. So what we are, and we also, next slide. Yes, please, sorry. So that was bite-wide example. Here I'm going to show you another example where we are changing the scale. So this is the scale at this is the plume scale. So what we are comparing here is model realization versus observation realization. Of plume visitation frequencies of the plume around ocean outfall. So what we are seeing here is just that the model is reproducing the same patterns as observed at the plume scale. It's also showing that the model is having the right intensities and the right direction, which means the plume is really traveling along the slope of the along the topography and along the slope exactly as we are expecting it to behave. So this is the second example where we are very visual, very showing how the model is testing the model if it's behaving the way it should. And this is the starting point before going into the quantification of the performance, quantification part of the validation. So once we agree, we are feeling very confident that the model is ready for the next step, we start next step. So next slide, Martha. So we did that for physics. We also did that for a series of for nutrient concentration, for phytoplankton, also for patterns for oxygen and pH. I'm not going to go through all the examples, but all the details of those comparisons are documented in our paper, James paper. So next, we move to the quantitative approach. So here we are going to assess the performance of the model. And the way we do that is by going through a process. First, we select the source of the data that we are using. And then we select state and rate variables that we are going to use. Third, we are going to identify the most important gradients for the question that we are trying to answer. And then fourth, we provide the performance assessment based on specific approach. So let's start with the first process, selecting the data. So in the bike, we are very fortunate because it's one of the best monitored area of the world. We have three categories of sources. The first one are remote sensing. We love remote sensing because they have spatial coverage. they have also temporal coverage. And specifically for ocean colors, for example, data started from the beginning when we start simulating the model. From 1997 to 2017, we have full coverage for chlorophyll, for STT, and salinity too. Second type of data comes from quarterly CTD surveys. So there are two types: coastal one, and then the offshore one, SCARCO. So the bite monitoring program has 5 different subregions, covers 5 different subregions, and then SCARCO is more bite-wide. So those are ship-based observations. They provide information about water column structure. They provide information about physics and about biogeochemistry. And the third one is what we call special studies. And those are bite regional monitoring programs that have been designed to understand or to quantify the biogeochemical processes. This example showing a map where we sampled process studies to measure nitrogen transformation, nitrate nitrification, nitrate uptake. Those have been designed close to the outfall, so in the near field area, and then in the far field area. So we have stations very close to outfalls and stations far from the outfalls to test, to check if there are to test the range of variability in terms of process rate processes. So we compare the model for through all those type of sources. And I like to put my variables into categories. I have 4 categories. Remember that we are answering the questions how nutrients are affecting cycles, oxygen and carbon cycles, ocean acidification and hypoxia. So 4 categories: ocean physics, nutrients with focus on nitrogen because it's the limiting nutrient in the bite, phytoplankton, oxygen and carbonate systems. So as you see in this graphic is the way that ocean physics would impact, would modulate nutrients from different sources, deep ocean or coastal sources, accumulation of blooms, sinking, and effect in oxygen and pH. So that's the reason we classified our categories into these 4 groups. And then I am having my indicators or my variables, my 4 categories, in addition to the state variables, that represents concentration, velocities, temperature, right? We also add what we call the rate. I have been saying rate inform about the process, biochemical processes. For example, primary production, phytoplankton growth, zooplankton grazing, nitrification, and other transformation rate for nitrogen. Okay, next slide. Okay, and then we had to decide about what to validate. What are the most important gradients? So we had agreements between scientists and managers on what matters for the system. For instance, vertical gradient is important because blooms happen at the surface or sometimes at the DCM, and decline in oxygen and pH happen at depth. So it's very important to understand the structure of the water column. So this is one of the most important gradients. Another one is bloom scale. We know that some tracers, like ammonium specifically, is more highly concentrated around blooms. So we want to make sure that we are also producing this gradient. And then we have some temporal gradients, like the monthly to seasonal to interannual variabilities. It's important to understand. We had good conversation yesterday about climate events, for example. So we are also trying to validate over those types of scales. Alongshore and foreshore gradients are also important because we want to understand how for example, the chlorophyll or the DCM varies from the coast to the offshore. So it's very important to have also that gradient. Next slide. Okay, so I'm going to go through examples now. So I told you how we quantify, told you how we collect what we selected the source of data, how we put our variables into categories. We selected the gradients. Now I'm going to show you one gradient, which is the horizontal gradient. And using rate data. We love rate data. NPP is rate data because it tells you that if you have chlorophyll right, it's because it's for the right reason. Here I'm showing observed NPP. Background is from satellite data. Dots are from in situ data from Capcom. Here I have, for winter and spring. In the right panel, I have modeled NPP, average over the same seasons of the same time, same years, 98 to 2001. So this is qualitative validation or comparison where we are seeing that the model 101 reproduces the seasonality. 2 are producing also the horizontal gradients over these 2 seasons. And then we have some quantitative validation where we are plotting this correlation. We are putting this correlation plot, where we are comparing the model versus remote sensing and the model versus Kapkoki NPP, and we are seeing good agreement over this domain. So this is first example of horizontal gradient using BGC rate. So it's a BGC by chemistry rate. And then now I'm going to go over the other type of data. Here is the quarterly survey where we are going to look inside the ocean. So we have been looking at the surface of the ocean. Now we are going to look more on the vertical gradient. So what we did here is extracted average profiles, and then we average or provided some statistics on the average profile and variability of the profiles by subregion. Going from San Diego, Orange County, Los Angeles, San Pedro area, Santa Monica, and Montreal. So I have here 5 profiles going from surface to deep, and then I'm plotting in red the model, and then the bars are range of variability in the model in space and time over this domain. And I'm doing the same for observation, right? Dots are observation, the shade is variability of the observation. And then we are going to work on every profile from this comparison. The next slide is going to show us what we quantify. So we selected 6 types of metrics that will inform about the model, if it's the model showing the right mean, the correct, performance of the mean. Some other metrics will inform about the variability of the comparison of the variability of the data versus the model, and others will inform about the shape of the profile or the goodness of the fit. So we have correlation, cost function, comparison of standard deviations, bias, etc. And we will provide that for every profile. So you will see that we do that for different seasons, different locations, and also in average. Okay, next slide. And then once we calculated all these 6 metrics for specific application, we use it to score the performance of the model. So we base our scoring criteria on the paper that was published in 2007. That was very specific to ocean, by the way, to ocean model ocean validation. So that ranked the performance assessment from excellent, good, reasonable to poor, right? So don't care about the numbers you are seeing here. So those are translated from this paper and applied in our performance assessment. And then what I'm going to show in the next slides are just the color coded from this table. You see that green means it's an excellent scoring according to those numbers. If it's red or orange means it's poor performance. I'm going to do a few examples. First example is white, all subregions collected together, averaged together. What we are seeing is that the model first is showing performance going from excellent to reasonable, right? So this is overall model is behaving as expected for different variables. So what we see here is temperature, ammonium, chlorophyll, oxygen, and pH, because those are the 5 variables that have been collected in the bite surveys in the coastal ocean. So, and then when we see that we have excellent scores, of course we are happy, right? When we see that there are some nuances of good to reasonable, we try to dig in, try to understand why we are not performing excellent. So, for instance, pH, ammonium, and chlorophyll. So we have oxygen and temperature, the 2 bookends, the best performers, and then the second performance are pH, ammonium, and chlorophyll. So in each case, we investigate the reasons why we are not having the right, the best scores, right? So what we did, for example, is one example I want to give is chlorophyll. We showed that we were off in chlorophyll in our count at some point, and then we tried to investigate the data. We found that we put in the model the wrong inputs, so we rerun the model. So that's one example how the process happened. Validation, test, check, rerun. We did that also for San Diego. We missed Tijuana River, data from Tijuana River at some point. So what we did is rerun the model, including the best data we could collect for Tijuana River, and it fits a bit better. Okay, next slide. So I'm just telling you this, how the process works. You validate the model, process, repeat, and try to understand why. Okay, so I'm going also to give example of the data quality where we had issues that we fixed. For instance, chlorophyll and pH. Previous validation, 1997-2001 that we published. Since then, we had new type of data, improvement in calibration for pH, improvement in calibration in chlorophyll A. We repeated the exercise, and what we learned is that we improved also the performance of the model, just because the data also was improved, right? So, yeah, for instance, chlorophyll A, after 2009, we worked with the community to provide new intercalibration, and also I also used some upgraded sensor technology. And I said for pH, we had a specific study by 13 that provided new sets of pH. Before we are still using pH from observation from sensors, but for that specific study, for 2 years we have collected data. We have collected, community collected, stakeholders group has collected data at specific with bottled data. So we had very high quality bottled pH with a range of variability of 0.05, and that would be a good example of a good slide. Okay, next slide. Yes. So that is my transition to my next part of the presentation. So I was talking. I showed you the method that we used in the first exercise for validation, all the methods that we use for the published paper. Now I am making the transition to what we are doing now and how we are improving our assessment. So next slide, Martha. So since then we expanded the model over 20 years. So we have longer time series, model and observation, of course. We also have some new data type in the more recent period between 2013 and 17. Okay, next slide. So what I'm showing here is the performance assessment in the first validation we put in the James paper. So what we showed is that, for instance, for chlorophyll, that we have good performance in some areas, we have some poor performance in others. Specifically for, not for the mean, not for the correlation, not for the shape of the profile, but for the variability of the data. And then we use the new calibrated data, and we reperform that assessment over 5 years. And what we got is an improvement of the performance assessment. Because the data was improved, the model matched better. So that's one example of how we processed the new type new type of data. Next slide. The other type, pH. The other example is pH. So remember that you would sensor data for pH with a measurement error that goes up to 0.4. That's huge for pH, right? So now we are using bottle data for the specific bite study for 2 years. So when we compare the model for 2 years over like 8 seasons, then 2 times 4 seasons, using an improvement pH again observations. And what we are seeing in the past, sorry, is very wide range of variability in the observations. As you see in the surface, some data goes from 7.5 to 8.3. That's something that is not possible in the nature. When we started using the new data, we see that the observations in average over the 2 years really are showing much better pH records. Surface looks very reasonable, depth very reasonable, and the line is the model, and the model is also showing some better match than what we got in the past. So that improved our performance assessment. So the caveat is we have less stations because it's difficult to collect more bottle data than the CTD cuts, but overall, the new pH monitoring data has really improved the performance assessment, and that also gave us more confidence in our assessment. While we have less confidence in the data in the first assessment that you have made. Okay, so now I am going to go through also new type of data that we are using. So we ran the model for 20 years, and those slides honestly have been made since last week because we tried to answer the questions and comments from the panel. So a lot of these have been processed in like 2 days. So yeah, it's preliminary results. We looked at 3 moorings. We have 3 moorings in the bite, and I'm going to show you examples mostly in physics because it's the first variable and we need more time to process the data for biochemistry. But the idea is to understand how the model is behaving in terms of temporal variability. Do we represent events? Do we represent the right signal variability? And do we represent the right mean over time, over 20 years? Remember that in the past 20 years, there is a lot of changes in the climate conditions, in the meteorological conditions. But there was also a lot of change in the nutrient management. For instance, starting from 2008-9, there was a lot of improvement in changes in nutrient inputs in some visual area. So we try to understand, or we are trying to understand all those processes and how they affect the condition in the bite, and if they are reproduced in the model. Next slide. Okay, this is one first example in Denmark. I choose the closest to the coast one because I try to answer the question about how the model is doing in terms of variability and in terms of climate cycle. So we have reports starting from 2010, not 20 years, but at least almost 7 years. It gives us good information about how the model is doing in terms of physics. I choose depth in purpose because what we are trying to understand is how things are changing close to the flow. What we are seeing is model in blue and observation from the mooring in orange. We see that the model is reproducing the seasonal cycle first, reproducing the overall fitting with the climate cycle. Remember 2014, 15, 16 were heat waves, so we see increase in temperature in those years. And also in terms of variability, of frequency, we see that standard deviation from observation and the model are very, very similar. So the model is kind of behaving. So those are preliminary assessments. So we are still digging on understanding more about those data, and we are also applying those comparisons for other variables nutrients, chlorophyll, oxygen, pH, whatever data we have. So also I want to show this example of how the model is behaving. It's been, but this is average over the byte for temperature going from surface to 80-meter depth. Again, byte-wide. What I'm showing here is that the model is reproducing what was documented in literature before. 1997, 98, El Nino, 2014-15, El Nino or warming, La Nina 2011, you see that the model is basically reproducing the climate cycle that we are expecting it to reproduce. Next slide. Now we want to provide quantification validation to what I just showed you before. So what we are using here is hero diagram, where hero diagram will give you information how the model fits the observation. So observed data is our is the code that you are seeing here, is our reference. So what hero diagram is telling you is if the model has agreement on the mean, closer to the observation reference. It tells you if you have high or low correlation, right? And then it tells you if you have your standard deviation, right? See the arrows, closer you get to the observations, more agreement you have on the variability. 3 parts summarized in one graphic. This is very powerful because instead of showing you 20 tables of performance assessment, I will show you this type of graphics where I'm plotting 20 years of temperature records, average, right? So overall, what we are seeing in the pipe is, example again, temperature over every year, single year, is within high performance assessment. So we agree on the mean, we agree on the correlation, always higher than 0.9, and we agree on the variability observation versus. And this is from comparison between Calcopy and
Wrap up. Why don't you just verbally wrap up?
yes.
Oh, there we go. Great.
Oh, good.
Thanks.
Okay, so another important, because of what we have shown yesterday is some of the effects of convergent nutrients happen in this area. For instance, offshore, south of Catalina Island, the persistent AD we talked about. We try to find data there to see if we can match the data. So what we found in one station, Calcopy, we don't have a lot of data, but that profile is very recurrent, is quarterly over 20 years, and it provided a nice comparison with the model over the 20 years. So what we are seeing here is temperature at 70-meter depth. We are seeing that the model and the observation, they agree both on the cycle, the climate cycles, more intense, or higher temperature in El Nino years, lower in La Nina years, and then cycle as expected. And those are like very, again, like I posted those in the past 3 days. Those are monthly records from the model. I'm not showing the high frequency, but I'm showing globally the method we are trying to use to validate the model inshore, offshore, over 20 years. So, and of course, I try to use the metric strategy to tell if the model is providing what score the model is providing. For instance, here is excellent because the model is fitting with the vertical profile in this offshore location. So, and of course, we can do it anywhere in where we have data. So yeah, so next steps. What we're still working on, like model validation is ongoing process, right? That we are talking about last week. So with partners, we are developing quality assurance screening on the data to make sure that what we are validating, the observations that we are using are adequate. And then we are also wanted to identify the key graphics. And here we really want to communicate with you, everyone in the panel, to get your advice, your opinion about what you think, what validation we need to do, what is missing, and if we are doing things right. And of course, we need to decide how we document those validations. Do we want to write paper? Do we want to have a website? Do we want, those are communication also with the rest of the community to make sure that we provide the right information for the people. And so what I have to today.
Thank you. Better on this. Thank you so much for the thorough description of all the validation and uncertainty. I think yesterday we started with people on site. Maybe we should start with Margie today.
Me? Is that okay?
Yes.
Okay. So just two questions that if you have done this, or maybe suggestions if you haven't. The first, and I apologize for those of you who know me, and because these are two things that I say often. But one is looking at AOU, so apparent oxygen utilization, rather than just pure oxygen. Because of course, because of solubility, if you do well on temperature, you're going to do well on oxygen, regardless of, even if you fail miserably at primary productivity and the biological processes, you're going to get the oxygen pretty well as long as you get temperature correct. So the idea is that with AOU this is the biological component subtracted out of from the solubility. And so that will really, from my modeling, I found it to be really the best estimate of primary production that we have, because of course, primary production measurements are fraught with uncertainty and very difficult to undertake. So, but we have a lot of oxygen data. So if you subtract out the solubility part and just look at the model, how well the model reproduces the remainder, you're really getting a good idea of how well the model can reproduce acidification and hypoxia. So that's one thing I would suggest. Does that make sense?
Yes, and thank you for the suggestion. Yeah, I'm used to AOUs, but I did not perform the assessment around it, but it's a good idea. Thank you for.
Yeah, and don't be dismayed. It's not going to look good. I'll just warn you right off the bat, but because it's really hard to get that correct.
It's informative, I know, yeah.
Yeah. So, and then the other thing is just and I am a little bit of a broken record on this, but for the Taylor diagram, just keep in mind that doesn't represent anything to do with bias. So you can get a perfect match and be a factor of 2 off. And so this we're never a factor of 2 off with salinity and temperature. So they work really, I find Taylor diagrams work really well for the physical variables, but in actuality, it's not that hard to be a factor of 2 off of something like ammonium and still do reasonably well. But you want to, that's the one problem with the Taylor diagram is you have to do a separate assessment on the actual bias, because the bias is subtracted out before you use the Taylor diagram. So just 2 little suggestions, things to think about.
Yeah, thank you very much. I think, we take that.
Yeah.
Yeah, I think that Taylor diagram would be always accompanied with the full performance assessment and comparisons with profiles. I think Taylor diagrams are very visual, very easy to show, in presentations. So very useful to inform about some variables and compare different variables. And yes, they will always have the rest of the documentation associated with the diagram.
And the other, so target diagrams, I don't know if you're familiar with those, but those show bias. they don't show the correlation, but they show the bias instead. So that's another type of diagram that you can use if you're interested in the bias.
Ah, yes, we will work on that with you. Thank you.
Great, thank you, Margie. And so now let's take some questions from the panelists here. Neil first.
So that was great to see so many things laid out, and thank you for pushing a little bit to show some of your current work, because that anticipated half my questions, which I've now crossed out. But along the lines of Margie's first question, I wanted to make a comment about rate measurements, because I think you're absolutely right that including a validation against rates is a way of checking processes in the model as opposed to just standing stocks. Really, really informative. But NPP, let's take that as the example. NPP is really a stock times a rate. And just as Margie is pointing out, a lot of the success in DO might really be success in temperature. I suspect that a lot of that you can't get NPP too wrong if your standing stock of chlorophyll is right. So have you looked at all to see how much of your, or first of all, how correlated NPP and chlorophyll or some other biomass are, and whether that is really driving the success?
Yeah, I mean, initially we made some comparison correlation between NPP and chlorophyll or biomass. They sound very correlated, but yeah, we did not go over too deep analysis on that point of view, specifically for this process. I think we did that for the 4-kilometer resolution model mostly, just to make sure that what we are seeing, we wanted to make sure that there is correlation, special correlation between chlorophyll and NPP, but not for the process point of view. So we'll work on that.
Yeah, it's a really hard thing to pursue, because mass-specific rate data are almost never included in monitoring programs. But I think for each of the rates that are up there, anything that can be done to push this issue could be really helpful.
Great, thank you, Neil. Mike, do you have any questions?
Sure, I guess my first is kind of a suggestion that it might be worth looking at some specific areas in the model that are within the domain that are particularly important for processes in the system. Like for instance, a lot of the upwelled nutrients come from the California undercurrent. So rather than kind of comparing to all of the nutrient data from cow coffee, it might be worth picking out, like station 9330 is often used as the one that's representative for the California undercurrent. So look for that at your subsurface nutrients, because that'll give you a good idea of whether you're upwelling the right nutrients into the system. So that's kind of my first suggestion. Then following up a little bit on Neil's comment about NPP, I was kind of curious in the NPP graph about a couple things. The first is, I think you showed satellite measurements, like the comparison to satellite on the left and cow coffee on the right. And there seemed like there were the same number of points. So I was just a little bit confused by that, because obviously we have tons of satellite and much less cow coffee.
Yes, for that specific, I picked the same point.
Okay.
That just, to make the correlation.
Okay.
Otherwise, not to have space.
I was also curious how you compared the cow coffee data to the model.
I integrated over space.
Sorry, no, continue.
Okay, yes, that's a good question actually, because I got a lot of this question about how we are comparing, what do we do. It's all about how we are sampling, right? So simply the model. What we do is in general, we average the model over month or over seasons, and we try to take the same, the closest point in the observation, and in time we average over the same time space. Of course, observations are continuous observation, but we average over time long enough to make sure that we have the adequate comparison with the model. Let's answer the question.
Okay, so it's not then a, like, Cal Coffee samples on January 7th, and you're not comparing,
That's me, I did that.
and you're not necessarily comparing to January 7 in the model, you're comparing to like the average of around that time?
Yes.
Okay.
The month of January, for example.
Okay.
We, in our analysis that we are trying to do now, I tried something. I did not
And-
look at the results, but I tried to do same day, 15 days around the day, around that day, and then 45 days, because
And-
this is the hint gap is not.
And are you focusing on just the vertically integrated comparison or also looking at individual depths?
Well,
Okay.
I showed the integrated one. I
Okay.
integrated both observation and then the same way. What I did is extracted the same depth as the observation and then integrated the same way. So I
Okay.
used the methods for the integration and in vertical space. That's
Okay.
the one, but we will look at the.
All right, thanks.
Can I follow up on the vertical profile you might just asked? So I have not seen any vertical profile of chlorophyll, or I know you're looking at the integrated or vertical profile MPP. What about subsurface chlorophyll maximum? Have you looked at that as well?
Yes, yes, we did that for every subregion.
Mhm.
Yes, we look at that. We look at that also with Calcoti. We document that in the paper, and we have also more analysis for Calcoti. And what we learned is that the model one is producing the deep chlorophyll maximum. Two, the model and observation both agree on the maximum depth where chlorophyll goes, and they agree on the seasonality of the profile. But deep chlorophyll maximum in summertime, more higher concentration of the surface in summer and in springtime. We disagree in the bloom sometimes because the observations are in such an observation, they can pick one bloom for 1 filament. You cannot produce that in the model. Same day, same location. But in general, there is strong agreement in seasonality, vertical profile, deep chlorophyll maximum.
Great, thank you.
We can provide more like wide or specific stations profiles for our comparison that we made.
So the Calcoti MPP data measurement was mostly on surface or it's vertical profiles as well?
Vertical profiles, but I mean, I think Karen, can you just remind me?
So that's a incubation measurement? Okay. And then there is, I guess there are new technology, like looking at oxygen isotopes or oxygen argon ratio stuff.
Yes.
Okay. Okay, so but that's at the discrete depth, and then you guys integrate. Okay, so the set comparison with the satellite was done on the integrated.
Yeah, integrated platforms.
Okay, sure. Great, thank you. Any other questions, Faye?
Thank you for making this comprehensive validation presentation. Also, the response to the comments, the document you just sent it to us. I think I'm convinced in terms of the model, the basic structure, and then the comparison with available the data. But there are so many other informations and data can be utilized for addressing the management questions, such as the outfall survey, and then, the moorings. You said that you only compare the temperature. So I don't know the detail, the mooring, whether equipped with oxygen sensors, pH sensors, and nitrate sensors, and those a high frequency continuous measurements at the key locations. That is going to be extremely useful, and especially at the different depths. I think that will be very important. The second part is really how to use remote sensing. The different estimate of MPP, there are 4 different methods. They differ by a factor of 2. So chlorophyll-based, carbon-based, absorption-based, right? So and so this is really a big uncertainty in the remote sensing community, how to estimate and NPP. So there is no standard per se. All right. So I think it's really is how to use that information. But I thank you for this very comprehensive validation process, but I need to focus on the key locations and then high frequency variability.
Thank you, Fei. Alex.
Thanks for the presentation. First of all, I want to acknowledge that what you've shown that's tremendous amount of work, looks like, right? Like you're working with real data with different formats, just getting the data, digesting the data, cleaning up the data, something that's a lot of technical work, kind of, that's really summarized in a Taylor diagram, but behind it, like maybe like months of Python programming and stuff, right? And some frustration on the way, probably. But I think it's very valuable. And what's in this whole presentation, what stood out to me is that time series plot, I told you. And I think for some, because it's really, it's much simpler than a Taylor diagram, right? You didn't have to explain what it is, right? You spend a lot of time on Taylor diagram. We still don't understand what it is. So, because why is it valuable? Because it shows like natural variability. And I think some people who sitting here in the audience, kind of, their main interest is like, okay, they have this ocean outfalls. And it's coming back to Fei's question, like, what are the management questions, right? There's so many data, there's so many ways to compare the model to the data, there's so many processes, and probably a person or a group cannot do all of them, right? And there's always like new ideas how you can massage the data in a model, right? But that should answer some particular questions. And I think the people who is sitting in the audience, some of them, I would guess, are interested to see like basically the nutrients input they would pump through in the ocean outfalls, how that does that compare to natural variability, right? Right. So, and how do you show that, right? How do you put, so where is that comparison? So it's still in the way, right? And I think what people in the audience some of them may also like to see, okay, so there are these outfalls and the model is a mixer, right? So basically we hope everything will be steered. We hope that something doesn't go to the surface. We hope something doesn't go to the beach, right? So we really have to kind of target those things, trying to use like synthesis of models and data. And with regard to that, how good of a mix is this model? So in the very first plot you showed this ADCP comparison, but like all the processes were collapsed into one plot, right? You basically you show the mean and the standard deviation. The mean is near zero because you have upwelling, downwelling. Yeah, but how does upwelling look like? How does winter look like? How does El Nino look like, right? What do you expect? So now we have El Nino. So do we have to expect like something unusual, something anomalous during this year? So stuff like this, so stuff that people are interested, right? And with regard to that plot, maybe if you guys could separate like wind-driven processes from internal tides, right? And treat those separately to show like, okay, our wind-driven variability is correct. And that's what forces the eddy fluxes offshore, right? The part that's not predictable, but hopefully predictable statistically by the model, right? And then internal tides, internal waves, right? You have a 300-meter resolution model. So you're supposed to resolve some part of it, right? So how much of internal tide energy do you resolve? Is it like 50%, 70%, 90%? So something that people like look at that and say, yeah, okay, these processes are represented by the model and these processes are not represented. Because you say the standard deviation is similar, but it looks like, to my eyes, like twice as small in the model, which is not surprising, right? Yeah, so it's usually, yeah, maybe noise is part of it for the data. So, and, but if it's 50% of observed variability, is it a good mixer, right? Or does the model reproduce like more confined plumes than in real life, right? Stuff like that, maybe. So anyway, thanks, it was fun, right?
Could I just comment on a couple things? You know, I think one of the things that you're already probably noticing is a big challenge is that, you know, you've been asked to review our research products. That, you know, have management questions behind them, but they also have, you know, there were NOAA grants or OPC grants, and so they're research products. And in doing so, they are scientific products in which we are forced to drop out 70 or 80% of the analysis and just focus down to tell a story publicly. And for the most part, that's what we've done because we're scientists. And that's how we grade ourselves, is by our scientific publications. I think the challenge that Faisal has, you know, in general, is that he's done a tremendous amount of analysis, that, you know, he's got graphic upon graphic. A lot of what you know, have sort of mentioned is different types of analyses that have been done that have either been shown in presentations to stakeholders. A little, we don't do a lot of reports, you've noticed that. But, you know, and so I think we're coming to this point in sort of this model application where we have to decide what is the right way to really start kind of showing these comparisons of interest to our stakeholders or other scientists, and what's the right format to do it, because scientific publications don't really cut it for that. And so I just want to make that point, is that we've actually done a tremendous amount of analysis in addition to what you've seen, way more. It's just then what is the right way to essentially show that, and to have it be useful to people. And so we're writing grant proposals around the idea of being able to do that data visualization and be in partnership with the stakeholders to have them drive what they want to see. But that, I think that's the next phase, and we haven't talked about that.
Martha, can I follow up on that?
Mhm.
So since you mentioned that you don't write much, that many reports, my question is why not? Is that, so the part of the grant or the projects you guys funded, is there building communication channels with stakeholders? And
Yeah, that's a really good question. So, you know, I think it really is who's funding the work. And if it's NOAA, these are competitive research grants and we have X amount of resources. We are trying to maximize our scientific outputs that are graded by the community.
Yeah.
And that affects our success in getting the next NOAA grant. So we will prioritize that work. And over time, I've been at Scrip now for 23 years. And when I started out, I wrote a lot of reports. And I noticed I didn't have any budget left to write the papers. And now we've switched that so that we prioritize the publications first. And so ultimately, I think the question is, who is this for and who's funding it? And then if that's what, if they really want to report with all the bloody details, that's possible to do. It's just that we have to, you know, essentially plan the resources to be able to do that. There's no reason why we can't. We just,
So it's just not built into the whole.
Yeah, because it's been a research program.
Okay, got it.
I think that's maybe the biggest message.
Okay, got it. I have a technical question for you. Since you mentioned that during the whole model calibration process, you know, you realize some bias here and there, and you have to rerun the model, several times. Just curious, how long does it take you to rerun the 20-year simulation?
Oh, no, we do not rerun the 20 years. We try to notice if there is mismatch in the first year. We do not, otherwise it's not possible. Like,
So how long does it take you to run a year?
Yes.
really 1 year.
Right.
Yeah. So it's 1 day for 1 month.
1 day for 1 month.
Yeah,
Okay.
1 day for 1 day.
So
basically,
basically,
day for 1 month of simulation is the average.
so 2 weeks for a year.
Weeks for a year.
Okay.
Yes. If I have no surprises with the server, it's
Okay, how many processors?
700. Average that I use for this exercise on the 764.
Okay, got it.
Yes.
Thank you.
Yeah.
Yeah.
And storage is also used for 1 year is about for 1 year is about 1.5 terabytes.
1.5 terabytes?
Yes, 300-meter resolution, byte wide, 6500 cells, saved daily for 40 variables.
Okay, got it. So I guess most of the computation is for the biogeochemical model because there's so many state variables there.
Yes, yes, I want to say 50%.
Okay, got it. Thank you. Neil, you had more questions?
there's so much to follow up on actually, but just on that last thing. Have you looked into at all whether you could get away with a reduced resolution version of the model for development purposes? Like if you cut it down to 600 meters, you know, it ought to run 8 times faster. You could do 8 times more parameter combinations. Have you looked into whether that would actually, you know, a lower resolution model would give decent performance?
Yes, good question. Yes and no. Yes, no, it's yeah. It's yeah.
Have to decide.
The decision about 300-meter resolution. We were tempted to do it at higher resolution. So we already got to 300-meter resolution to find good compromise between the computational problem and covering the byte, and more importantly, processing or treating the plume the way to treat it. So yeah.
So I don't think you quite answered the question, which was, have you ever looked into doing it just to use it to guide some of the model decision making? And the answer is not for the main ROMS-BEC sort of anthropogenic nutrients. You know, the sensitivity analysis is a place where you could use that. It's arguable whether or not we would want to. But where we have used it, and it's being used right now, is we have another component of the work that you've not been asked to review, which is for toxicabs. And so it's being used to really look into sort of early verification sensitivity analysis for our toxicab model at 1 kilometer within the byte. But we haven't brought it back to this work. We don't really see a need for it yet. As a side, I suppose we could. The other way that I'm thinking about it, and we just wrote a proposal around it, which is, you know, if we want to sit down with managers and say, hey, let's start tweaking a bunch of knobs, you know, let's try out different sort of realistic combinations of load reductions, not everywhere all at once, then we could probably run that at 1 kilometer and get a vibe check that if we gave it back to managers would help them sort of make decisions about what they wanted us to run realistically. Then it would help to narrow scenarios. That's a really great way of using that. So I thought about that, just wrote a proposal around it. Anyway, that's the answer to your question.
Okay, thanks. If I can, I mean, we've gotten up to such a wonderful high level. I had 2 very tiny things. Thought I'd ask while Karen and Jim are here, just about possible data to bring into the validation. One was, is there any historical information that looks directly at retention time in the offshore waters in the area of the, you know, recurrent eddies that seem to be so important? Because you could calculate that kind of thing in a model with a Lagrangian calculation or something, but you need something empirical to compare it with. Is there anything like that?
In the upper ocean, offshore. Retention time. Never heard of it.
They have been talking to your site. What kind of
Okay. Right, and the other thing was, is there, I think I know the answer, but carbon biomass or POC to go with the C14 incubations? That, oh, there is. So you can actually biomass correct those and get an intrinsic rate then. That work?
Except that the POC, a large portion of POC is not quite things that a lot of try to simulate. So
Right.
you can get something useful, but then it comes to how's the model representing detritus.
Are you talking about terrestrial detritus or just dead organic matter? Okay.
In surface waters, but there might be something there, just to follow up on my comment about stocks and rates from before. There might be something to poke at there, a different way of using that data to separate the rate itself.
For samples here series, there is phytoplankton carbon measurement from the cross. So you could do that directly for a portion of the series, and just following up it, like it is really good to see if you're getting the turn on cost. And you can do that for it's like 10 stations and 10 years of cut off of that. Okay. Great that probably we're out of time. I bet yes, I gave you
Yes, Archie, you have a quick follow-up question? Give you another chance.
No, I'm good, thanks. All interesting.
That's all. Well, thank you very much. Appreciate it. Okay, now we're gonna, okay, now we're gonna take a moment to transition to the next part of the agenda and move to technical session 4. Yeah, so now we're gonna bring up Amber Baylor, and Amber's gonna come up, and we're gonna introduce a couple of gentlemen to speak to us today who've got deep ties to the Scripps Institution of Oceanography. So we've got a lot of representation from that group today. But I want to bring up Amber so she can introduce Andy Lysing and Scott Jenkins. You the podium. Thank you.
Hi, good morning, everyone. My name is Amber Baylor. I'm the Director of Environmental Compliance for the South Orange County Wastewater Authority. Today, I have the pleasure of introducing Dr. Andrew Lysing. He received his bachelor's degree in biology and marine science from the State University of New York at Stony Brook, and his doctorate in biological oceanography from the University of California, San Diego, Scripps Institution of Oceanography. Oceanography. His research focused on the ecology of marine crustaceans and their behavioral responses to environmental variation. After graduate school, Dr. Lysing conducted further field experiments working on the behavior of micro and macro zooplankton under varying food and temperature regimes at the University of Washington, Seattle. He also conducted computer modeling experiments, ecosystem responses to oceanic variability and climate change. Currently, Dr. Lysing works for the National Oceanic and Atmospheric Administration's National Marine Fisheries Service, NOAA Fisheries, at the Southwest Fisheries Science Center in La Jolla and Monterey. His current work focuses on the responses of fish and zooplankton to climate variability and the characterization of oceanic variability. For example, marine heat waves to climate change through his work as part of NOAA's California Current Integrated Ecosystem Assessment, or IEA, with his team. So with that, I'd like to introduce Dr. Andrew Lysing. He'll be providing our first presentation, which we'll move on to the second presentation. I'll introduce Dr. Scott Jenkins. Thank you, Dr. Lysing, for coming.
Thank you, Amber.
Thanks. I'm gonna keep my coat on. It's a little chilly in here. So nice to see everybody on the panel. Some of us are old friends. So great. Can I have the next slide? Actually. So just to give you a little background, why would NOAA Fisheries be interested in this modeling effort? Well, obviously because fish need oxygen. So we have a pretty vested interest in knowing what's going on with the oxygen. And we're actually, I'll let you know, we're somewhat desperate to have good oxygen measurements, especially off the bottom. It's becoming an increasing problem in various places over past years. We get some oxygen measurements from our surveys, but they're kind of far and few in between. So having a good model out there to predict and give us some estimates of oxygen to fill up the gaps would be really great for us. So we're really looking forward to having something like BEC succeed. Next slide, please. So just why the heck am I here talking to you about this right now? Just to let you know, I've been sort of following the progress of this BEC model for about 4 years now. NOAA Southwest Fisheries was asked to have a representative here to see what was going on, and that ended up being me. But my personal history, I actually worked as part of the JGOFS program quite a long time ago, 20 years ago now. And that's actually where the BEC model got its origin with a fellow named Moore who worked on that. And so we actually worked on different modeling projects sort of together in those projects in those years. And then after that, I've actually was also part of a group called Pisces, which developed a similar kind of model to BEC. It's called NMRO. It's another model that gets commonly used here in this coastal system. I've also got a lot of history in this specific region. I've led the Cal Coffee State of the California Current for several years. I put that together, and then I'm also currently now the lead of NOAA's Integrated Ecosystem Assessment team for doing the ecosystem status report, where we look at data from all across the entire California Current, including the Cal Coffee region. We put that together every year to report to fisheries. So that's a ton of observational data. Next slide, please. So there's a lot of things that actually work really well in the BEC and the overall model. And Just to give an example, there's the biogeochemistry, the oxygen and pH, I think are handled really well. And those are some great advancements. And I think this modeling effort is really good as an academic model. So I'm not going to spend time on those. I want to show it, just point out some things that give me a little pause as we move from this model being what I'd say is an academic model to more of an operational model that some people like me would want to use for getting oxygen. And I have two primary concerns that I'm going to talk about, and that they're mostly to do with the actual kind of some of the base structure of the NPZ components of the biogeochemical model. And NPZ just means nitrogen, phytoplankton, zooplankton. It's the actual boxes in this model. Next slide, please. So the main paradigm, as I see it, and I think Faisal also mentioned this, is that we have diatoms. This is my idea of looking at the water column here. So we have a bunch of diatoms. We get nitrate coming in. You can get ammonia from the outfalls. You get nitrate coming in from upwelling, and we have those things growing in the surface, right? Next slide, please. What happens is these things, diatoms, have silica shells. They're big and they're heavy. So once they bloom, they die. They sink down, they sink rapidly, and all the things that eat them form fecal pellets that also sink rapidly. This stuff sinks down. Next slide, please. And they die, okay, near the bottom, and that uses up oxygen, changes the pH. Okay, so that's the base paradigm we're working with. Next slide, please. So this is what I'm saying here. There's I believe, an important missing component to this overall model structure, and that's dinoflagellates. Okay, dinoflagellates are really important in this area. They actually are something that can sometimes compete with diatoms, especially for ammonia. These things are built to take up ammonium. They also love stratified waters, which is something we have a lot of the times. And next slide, please. So I have kind of a list here. I'm not going to belabor this too much of what dinoflagellates do in this system, but they're a really important part of this system. And it's hard to see how a model is capturing some of the important dynamics here. And so if you get nothing else from what I'm going to say, I would say moving forward with this model, a big improvement that would take care of some of the uncertainty would be to put dinoflagellates in this model. And I think this will help in a huge number of ways, improving the model and moving it forward and doing some of the other things that were just mentioned, especially with harmful algal bloom monitoring particularly. So anyways, there's a list of things here. I'm not going to belabor it. Let's go on to the next slide, please. So what if we had dinoflagellates in the model? What happens? Next slide, please. You get less sinking because these things don't have big carbon, or I mean big silica shells. They don't sink out once they bloom. They kind of sit up in the water column. Next slide, please. So there's less stuff dying down in the deep. Next slide. Okay, and so you get a pretty different dynamic. So one of the issues here is that you could get the correct net primary productivity and the right amount of chlorophyll with the model as it is, but it's a big difference whether you're splitting some of that primary productivity into the dinoflagellate box versus the diatom box, okay? And that's what I would argue is an important missing component here to help us understand some of the uncertainty, especially around comparing the model with observational data and with predicting oxygen. So next slide, please. So I think some of the ways, though, you could address this would be a much more careful review, particularly of the sinking rate parameters on this, right? So could you hybridize the model as is somehow to account for that difference between dinoflagellate and diatom sinking? Is there a way you could fix it somehow there? Next slide, please. Okay, so again, some of the pause here too is that the BEC model right now, some of it has some of the same parameters that were used for the original version of this model developed for the equatorial Pacific. So again, a reason to review those sinking dynamics very carefully. Next slide, please. Okay, and then another one is, of course, the remineralization rates. Those are going to be different if we think of, well, maybe some of this is not diatoms, but maybe some of it's dinoflagellates. Next slide, please. Okay, but I think really the best way to do this would be to really, and I know, Neil, you mentioned this, got to have a damn good reason to add more complexity to the model. And this would be essentially adding another box. I would argue there's a box in the model that's not very useful. The model has trichodesmium, the nitrogen fixer. It does very little, I would argue, in this region. I don't see why you couldn't convert that box to dinoflagellates. It's already, equations are in the model to follow this, to run around the model, parameterize it, everything. You could just change that into dinoflagellates. It would take work. I fully see that. It would take quite a bit of, it would take a significant amount of work to do it, but it's there and it's a box that I don't think is currently being used and could just be put in as dinoflagellates. Next slide, please. I'd also note that This is a really interesting paper from 2017 where there was actually a diversion at OC Sanitation, and they followed exactly what the response was in chlorophyll over this diversion. So this is the ultimate, we're pumping in a bunch of ammonia from an outfall into the coastal environments, and they followed what happens, right? So this is a great paper to see what the response was like. There was a chlorophyll response on the left, there was a diatom response, and then the diatoms went away. Okay, so we know they're out there, and we know that they're primed to respond to these kind of point ammonium sources. So having them in the model, I think, could only improve this model and really push it forward. Next slide, please. Okay, so that was my first big concern. You get nothing else, take that away. Second major concern has to do with grazing in the model. Okay, so this is essentially, when we say NPZ, these are the boxes. We got the N nitrate ammonia. We've got the P as diatoms and Z zooplankton. Next slide, please. So normally what you do in these NPZ models is you have some kind of predator that's eating the zooplankton. Next slide, please. But that's not in this model. There is nothing beyond the zooplankton box. Okay, so then you have to say, well, what kills off my zooplankton? Because my zooplankton ultimately control my phytoplankton. Next box, please. So what they have in this is something that's done in many models, and it's called quadratic mortality. And what it essentially says is the zooplankton eat themselves. Okay, the zooplankton eat themselves at a rate proportional to the zooplankton that are there. Okay, so next slide, please. So that is something that gives me a big pause in this model, particularly because this model is now being used to look at perturbations at these short time scales. Having quadratic mortality works good for large global ocean models where you don't have these quick perturbations, but it doesn't work well where you have these input perturbations. So this is a super simple 0D model I cooked up just to point this out. And what's different here is what I'm showing is two different scenarios, same starting concentration of phytoplankton, zooplankton, and nutrients. And what I do is I have a slightly different value for this B that's in the death equation, okay? And what happens is at some point I threw in some more nutrients to see what happens. And what's problematic thing about the quadratic mortality is that in one case, I can throw in the nutrients and the system returns to its former state, okay? In the other state, slightly different value of that parameter, throw in the nutrients and it changes state. Okay, and the reason is because in one case, the zooplankton can control the bloom, and the other case, the zooplankton can't, but it's because they're eating themselves. And that's not really how it works out here, especially in a system that's eutrophic and it has microzooplankton, macrozooplankton, even larger, non-plankton, but fish and other things eating on them. So that the trophic web in a coastal system like this is a little too complex, I think, to parameterize as a system that is like an open equatorial or global ocean model where you can have this rapid cycling because there's lags, okay? Copepods take time to gear up and respond to phytoplankton presence. Okay, so there's lags and things inherent in the actual system we have that aren't really well expressed in this. And again, this could be one of the reasons it could easily explain some of the problems in matching the phytoplankton in the model to the actual observational time series. So addressing this issue could really help with some of those shorter time span temporal mismatches of the model. Next slide, please. So anyways, I'm not going to belabor this again. You guys have all the slides, but there's a great paper, Edwards and Ewell, that came out quite a while ago that talks specifically about the use of the quadratic mortality and its pitfalls and caveats and problems. Again, it's something people say, well, why would you use it? Well, it's good in that it does provide model stability. So that does help in that sense. But I think in this case, my recommendation would be you need to do an even more detailed of this grazing, the way the grazing works in this model, make sure that's not what's causing some of the matches and mismatches. Next slide, please. So just to kind of wrap up, what are my two big concerns? Adding dinoflagellates or addressing somehow the lack of dinoflagellates. I think, and then the more work on the sensitivity specifically on this, around this grazing control, what's in the model, especially since you are looking at these episodic perturbations to the system, and it's a coastal eutrophic system, not a global ocean system, which is what BEC was originally designed for. Again, I think sensitivity analyses, good point about, there's where's the money come from to try to publish or produce reports. None of this, I don't think all of this needs to be published, but a lot more of it needs to be just, I mean, think made available somehow, some kind of report, a table, something, I don't know what form it would be, so that people can look at it a little more specifically and see, dig into the nuts and bolts of where it matches, where it doesn't matches. That would help address a lot of uncertainty. And then I think lastly, there's actually still a few little technical details I don't want to get into too much. They're in the model, that are in the last published version that shows what the equations are. Some of them are a little strange. So there's something that's still listed in there that there's a depth limited grazing. I don't know if that's been removed or not, but it's actually, according to the paper trail, it's still in there. There's a reference function for how temperature controls growth. That's actually not that well documented in the papers. And we've heard before talking about how this model was tweaked to not be the original HNLC Equatorial Pacific model, and it's been tweaked towards the coastal zone. Some kind of listing of more specifically what tweaks were done would also help to understand how the model's been adapted to the coastal system and how we can interpret the results better. I think maybe that's it. Next slide, please. Okay, so this is too much to read through. Take a look at it later if you want. This is my standing on the box ideas about some more things that could specifically be done with sensitivity analyses to address some of the outlooks on this model. And next slide. And I included just a list of the references to some of the things I talked about here, so you have access to that. Next slide. Even more about MPT. And that's it. That's all. I just wanted to be brief and try to hit my high points there. Thank you.
Thank you.
So thank you, Andy, for the concern of the list of the potential issues you missed. And any questions from panelists?
Thank you, Andy, for keep those 2 points, kind of flagellate and then grazing and other things. There is a label called small phytoplankton in the model. I don't know whether the team can explain the difference or that small phytoplankton in the model versus the dinoflagellate that Andy is referring to. But fundamentally, I think there is only one class of zooplankton take care of 4 classes of phytoplankton. So there are some zooplankton prefer diatoms, so there are some zooplankton prefer dinoflagellate. I think this is fundamentally not just the grazing parameterization will be able to resolve that.
Yeah, I agree.
Did you want Faisal to clarify whether or not? And I would have to say, I apologize because originally all of these presentations were scheduled for the 17th. So Daniele Bianchi was planning on being here yesterday to answer any of these types of questions and then sort of anticipating this conversation, but it got switched. And so, we have Faisal, who's part of the biogeochemist, so he has some of that, but I think that Daniele in particular has been working with the model extensively over the last 5-6 years, doing a lot of essentially, thinking about its applications in fisheries as well as toxic HABs. And so there's quite a bit of effort into it. And so I think that I'll just, I'm the science communicator, right? So guys, correct me if I'm wrong here. First of all, dinos are included in the small plankton class. Second piece is that when we think about, Andy, first of all, great presentation. Thank you very much. And Andy's actually been with us. He's been, a great community science advisor. So this is a healthy discussion. What I want to say is that when we think about cell abundances, that can lead you down a path that you may want to say, should that steer our model choices? But ultimately, what we're thinking about is the contribution of those cell counts to total bio volume. And so, what we know from published studies is that 80% of the biomass on average in the bite is diatoms. So if we're capturing that main signal do we need to add additional components, or should we be parsimonious? Because we may not have the right ways to parameterize everything that we add. So I think that that's a fair question, and I think that it's a fun sort of topic of discussion then, because there is great interest. And in fact, Jim's working on a project right now in which, starting to sort of push back to marble, and that we would have more opportunity to play with phytoplankton classes. Not so easy in back because it's old clunky code. So from a research community perspective,
It was funky when it.
So from a research community model perspective, there's great interest in really understanding this, because it's essential for us to get this sort of greater proposition correct if we're going to be using these models to direct climate change and a lot of other applications. But the question is, for this, do we invest to add this functionality? And I think that's a fair question. The second point I would like to make is that because we don't have the team here, we'll have our team listen to Andy's presentation and then provide a response to comments, and that's probably a fairer way to do it, because that's not me. So.
Well, but I could partly answer. So the small phytoplankton in the model, if you look at the rates, so the uptake, the half saturation, and the max growth, those are cyanobacteria. They're not diatoms.
I think maybe below you can, since you've been running the model yourself, so I think you probably have good idea on the details. What's fundamental difference between the large phytoplankton, small phytoplankton. I don't know whether that's your choice whether to respond to that.
And problem, I think, of course, I would not give you the exact number that we have in the model for the rate, but they differ in the rate. These are size spectra groups. So I mean, I'm not talking about functionality for speed items, but the small phytoplankton is supposed to group with small phytoplankton, right? So with different there are some decisions that have been taken to represent the average non-diatoms. We call them small phytoplankton, non-diatoms. I want to call them because the difference is how they uptake silicate more, and then also in the rate how they uptake ammonium on the rate. While they represent most cyanobacteria or diatom or the diatoflagellate or average of the small phytoplanktons, that represents 20% of the biomass. Those decisions have been made by the team in terms of rates. So, but I cannot speak to exact numbers and why, because this is a long history of model development.
Well, so for that, Curtis Daniele, that's the team.
Yeah, go ahead.
Let me make call it a high level comment. I'm a tourist in the land of ecology. I was introduced to that land by a man named David Chapman, who left his record in the plankton community. And one of his first remarks to me is that given the physical circumstances, there's nothing more predictable than the occurrence of a plankton bloom. And there's nothing less predictable than the succession of species that will follow. The deep issue here is to what extent you can, in a controlled way, open up species competition for species that are essentially in the same functional niche. And my sense as a tourist is that's a deeply unsolved problem in ecology. I think the philosophy behind a model like this, to pick another phrase, is that there are lumpers and splitters, and the biologists love to split, and people who make system models like this love to lump. The criticism that is being made here is one of, hey, maybe you've lumped too much. Maybe you should explore these avenues, the predation avenue, whether the dinoflagellate contribution is being adequately represented by the small plankton. These are all perfectly, and remineralization, which you mentioned, less, but I think that's a deep frontier. These are all great research questions. But I don't think at this point there's evidence to say that the degree of lumping in these models is excessive from a system performance point of view.
Great, thank you for your input, Jim. And Mike, is your question related to this conversation or Margie have maybe? Okay.
Yeah, mine is pretty related. I think I'm a lumper, I guess. Hadn't really thought of that before. But yeah, so I just wanted to like maybe put my perspective on a couple of things. First, Andrew, great presentation. You know, you definitely highlighted some really important things. Regarding these are things that I struggle with too and have for years, decades. And regarding the diatoms and dinoflagellates, again, I think my our philosophy is to lump until you see that you really can't lump anymore. And maybe that's where we are right now. I mean, maybe so many of the lower hanging fruit, the easier things have been improved in the model that this might be the next really big thing to look at. I think in my view, going back to our overarching questions, can we use this model for management questions? I think maybe, even though it lumps, my gut feeling is that perhaps, yes, it could still be useful. That's not to say that we consistently don't want to continue improving the model, and this might be another one of the next improvements down the line. And there are, and I think you were kind of getting at this. There's a number of ways to do this. I mean, I love the idea of getting rid of the trichodesmium. That's, just the holdover. It just is like, oh, this was just a holdover from the open ocean when at a time when trichodesmium was the hot thing. Let's get rid of that. And replacing it. I don't think it would be that difficult to do just what you said. So yeah, I'm for that. On the other hand, there's other ways to get around this. And one of the ways that we do in the Chesapeake Bay, we have one group, but we use the temperature so it's diatoms in the early spring and dinoflagellates in the summer. And so we have a temperature formulation so we have growth rates and grazing rates and all these and sinking, all those rates are temperature dependent to act more like a diatom at those temperatures in the earlier spring, and then act more like a dinoflagellate. So we only have one box, but it changes throughout time. And I would argue that, although, and I don't think you disagree with this, but just, it feels like, how can we have a model that works that it only has a diatom box and is completely missing this other important species, which maybe isn't that important, but even if it was, and I think it does that by not truly being a diatom box, but it's some combination. It's a box that is characteristic of 80% diatoms, 20% dinoflagellates, and that's how it really performs as well as it does. It doesn't have the sinking rate of a diatom potentially there. It is a sinking rate 80% of the way towards a diatom and 20% of the way towards the dinoflagellate. And I think that's why it's done as well as it has in the past. So anyway, those are just kind of my thoughts on the issue.
Great, thank you, Margie. And I think in the interest of time, I'm moving on to Mike's question.
Yeah, so you're preaching a little bit to the choir here, Andy, as someone who likes to teach my 2-year-old about dinoflagellates because they're so much fun. And there are times where they're really important in this region. I mean, I've been out there when it's just a soup of dinoflagellates. But I agree with Margie that in the model, they're often, if you have only a diatom, and I mean, this is true of Nemero as well, the diatom is part diatom, part dinoflagellate, and really it might matter that we're getting this wrong and it might not. And a lot of that comes down to, are we getting the flux out of the system right? And that's something that we can check, because we've got a lot of measurements now of sinking carbon flux in the California current. So we can just compare to that. And if the model's getting that right, then for this particular purpose, it's probably fine. The zooplankton issues that you brought up really concern me if we tried to use this to predict fish food. But it may be perfectly fine for the current applications. And so it's just kind of some of these things to look at and think about for the future, because there may be other applications in the future that you want to add to this. And it may be that the current formulation is fine for this application. And there are just some other things that we can check into and look at.
Thank you, Mike. So I know Neil, you think a lot about content as well. Do you want to comment on that as well?
Yeah, I think the comment I really wanted to make is I think, Andy, you did a great job of pointing out, fundamental issues that could, under one design philosophy, make you say, oh, you have to start completely over with trait-based models and 600 boxes and whatever, or there are particular parameter values that you could look into carefully. And I think that, just to take the dinoflagellate question as an example of the two issues, even if, that I agree that concern about the role of dinoflagellates means you need to look carefully at sinking rates and remineralization rates, especially if the parameters are adapted from a different part of the ocean. But even if everything in the bite was a diatom, you would still need to look at sinking rate and remineralization rate because diatoms are diverse and the processes are uncertain. So I think in terms of practical next steps, I think probably, there's, I have a feeling that there will be a sort of like a practical way forward that we can recommend that doesn't require consensus on the, deep questions like lumping and splitting.
Thank you, Neil. Any response?
Just to sort of reiterate that what I like about this conversation is even to help the managers understand the importance of the fundamental research that goes into the community models that builds the consensus to the point where it's elevated and then gets ported over to the management model. And so I want to reiterate that our teams, and you can see SCORP and UCLA together at this table, understanding that these pieces are inextricably linked, and that, I think there's a lot of work that we haven't talked about that is moving towards, Marble as the foundation to port back into. That would make it much easier for the entire community to do research on these questions, that you don't have to have specialized expertise in manipulating that, right? So that, I think that's just really a big part of where the long-term vision of where we would like to see this research go is to be able to kind of really have the duality of community research with management applications going forward. That's, however the chips fall in the management question, great. But long-term, what we really want is that vision to go forward, people getting used to using models for decision support. So that's the skin that we have in that game.
Great, thank you. So I think
In considering the timing here, someone mentioned a climate change, the IPCC class, the model types. The reason the public, most of them accept that type of modeling approach is a multiple models assembled together. So we are talking about one particular ecosystem model structures, no matter how you change it, is bounded with that nature of the model structure. Therefore, it's a back, a marble, or emerald, cosine, whatever. So there is give you the diverse of the ecosystem model structures difference, maybe that give you an envelope instead of one line of, again, this is the same paying attention, but this is a tremendous effort. Jim may not agree, but so this is just been thinking, been doing this for quite some time.
Well, I think that, it's not sufficient just to model, like you have to observe and you have to synthesize all the observations to make sure that even what you're learning really jives. I know that Jim has a lot of experience on sort of global climate modeling and can opine on that, but ultimately I want to go back to speak to your point that I think that the community here has been engaged in observing with our partners, including the POTWs for greater than 20 years. And so when you think about your recommendations, think about what investments and observations would be useful to your point then.
Thank you, Matt. Jim, but could you please make it a bit short? We can move on.
Yes, trichodesmia matters lots of places. We want a general model, not a regional model. And secondly, Beck and Marble have had essentially independent developments for 10 to 15 years. We're about to engage, if somebody will pay us, into systematic comparisons across the Pacific of two independent classes of solutions. And I think that will be very informative, working towards phase point of multiple models do expand your view, but by the way, oceanography has never paid for them.
Great. Thank you, Jim, and also all the questions and comments. I think in the interest of time to move on.
Thank you.
Andy, I heard you are going to stick around. If you have some questions, we can ask you. Thank you.
So I'm not sure if you can be a lumper and a splitter, but I think I might be both. But I have to take some of the technical details and translate those into some of the management applications. And I'll just remind the panelists too, and full disclosure of why we're here and bringing Scotty. We're looking at this as a question of implementation into our permits. We actually evaluated 6 different technologies. And in this evaluation of the ROMS-BEC model for management applications, for compliance with our permit, we actually retained our services of Dr. Jenkins to help us understand, because we weren't modelers, what these really were and those implications. So Dr. Jenkins will provide some presentation today on the work that we also provided to the San Diego Regional Water Quality Control Board on some of our findings that we also shared with this group here. So it is my honor to introduce Dr. Scott A. Jenkins, who received his BS in chemistry and physics from Yale University in 1972, and his PhD in physical oceanography from the Scripps Institution of Oceanography in 1990, where he worked for 35 years as a research faculty. He is currently the technical manager of coastal science and engineering at Michael Baker International and an emeritus principal engineer at Scripps, University of California, San Diego. He is an author of over 80 scientific papers in coastal processes, numerical hydrodynamic modeling, sediment transport, sedimentation control, and autonomous underwater vehicle technologies. In addition to this AUV experience, Dr. Jenkins has 23 years of plume hydrodynamic modeling experience of both wastewater ocean outfalls, as well as brine discharges from ocean desalination plants. His plume modeling studies have supported both EIRs, EISs for desalination projects, and NPDES permit renewals for existing wastewater outfalls, including the South Orange County Wastewater Authority, and for cities of Carlsbad, Huntington Beach, Long Beach, Santa Barbara, Santa Cruz, the Los Angeles Department of Water Power, and West Basin Municipal Water District. So with that, it's my pleasure to introduce Dr. Scott Jenkins. Thank you.
Thank you, Amber. Well, these are, of course, are the charge questions, and I think they all really distill down to the question Professor McWilliams asked about research models versus operational models. And in the context of this being a decision support type of thing, it would be regulatory model, operational regulatory models. Next slide. So I received from Squirb codes for the ROMS-BEC model, and there are like 231 Fortran codes written in Fortran 90, and 57 of the header codes written in C, and that drive the model. And then with regards to non-hydrostatic ROMs and Croco, I never was able to get readable source code. We did get assembly codes of ROMs and non-hydrostatic ROMs written in assembly language, but we're not able to see the actual source code. But from the codes I did review, I came away with a couple of concerns, and these concerns arose from my early work at Scripps. We received principally our funding was from the Office of Naval Research, and in 1993, I received 3 years of grant funding from Code 322 to pursue one of the Navy's first attempts at a ROMS-BEC model. The Navy's interest in this was because they were using multispectral scanners on airborne platforms and on satellites, and they were able to see underwater targets of interest. And so they wanted to know the parameters under which they would be able to identify underwater targets remotely. The concerns that I have after looking at the codes from this prior experience is that I'm concerned about the ocean optics in BEC. It's rather primitive, and it only considers light attenuation due to absorption. It neglects light attenuation with depth that's the result of scattering. And the other one I'm a little concerned about is how the ocean outfalls have been schematized within non-hydrostatic ROMS and within hydrostatic ROMS. And then I have a third worry that arises from these two concerns. But the ones I list there, they would seem to impart a bias that would overstimulate algal photosynthetic rates, growth rates, and NPP, while under-predicting the dilution from the outfalls themselves. Next slide. So regarding the first concern, these are the basic processes that are involved with the attenuation of light. What the model considers is absorption of light, the present model, and it considers absorption by the water molecules and by the plankton. It does not consider backscattering of light from the plankton populations, nor does it consider backscattering from all the other inorganic particles that are out there. And it's those inorganic particles that are extremely abundant when you get into coastal waters. Next slide. Okay, so the ocean optics problem is basically solved by Gustav May, way back there. And the concern is the attenuation of light from the PAR band, photosynthetic available radiance. And the formulation that I found in the codes written by Curtis Deutsch and Hartmut Frenzel, the formulation is in their terminology shown there. The light attenuates exponentially, and the rate of attenuation is controlled by the diffuse attenuation coefficient. It's that diffuse attenuation coefficient that has been oversimplified in my view, and especially based on the experience we had with field validation back in the 90s. So the first term there is what's in the model. It's got the absorption of light due to the absorption coefficient A, and it neglects the second term in the brackets there, which is the scattering effects. And it consists of a scattering coefficient and a volume scattering function that determines the direction and intensity in which the light is scattered. The unique thing about the second term is it depends on a different type of concentration. Depends on particle numbers of a given size per unit volume. That's different from the concentrations that are being used by the Deutsch Frenzel model. And the next slide is right out of their code. And if you look at water. Now, over in Europe, BEC has done basically light profiles throughout most of the coastal Western Europe and the Mediterranean. And this is the range of diffuse attenuation coefficient that was measured. And it's a little bit of a reverse rainbow scale where violets and blues are high numbers on the range of almost 2, and low numbers are on the range of 0.04, which is pretty close to just the absorption coefficient of seawater. So far off in the oceanic environment, the absorption coefficient and the diffuse attenuation coefficient are almost one and the same and very low. But as you get into the coastal waters, particularly those of the Biscayne Bay, the North Sea, and the Baltic, you'll see that the numbers get quite high. And this is very close to land in the coastal zone. And similarly in the Mediterranean, which is somewhat nutrient starved over most of its water mass, still where you have rivers like the Nile in the southeast Mediterranean, you see again very high levels of diffuse attenuation coefficient. Next slide. So this initial ROMS-BEC Navy model, we did our validations off Camp Pendleton. And what you see here is a multispectral scanner image from an El Nino flood in the Oceanside Camp Pendleton area in 1993. So you see the river plumes quite well. And the little numbers on the contours are particle number concentrations in terms of on a base 10 log scale. That's a particle number per milliliter. Now, next slide. What we found from doing actual measurements of attenuation with a laser attenuation absorption meter, wet lab device, we were able to separate out the various components between absorption and scattering. So the scattering coefficients are shown on the left column versus par wavelength, and the absorption coefficients are on the right-hand side. And you'll see that the scattering coefficients, when you get in the coastal zone, they're 2 to 3 times greater than the absorption coefficients. So this is the result primarily of the inorganic particles. Interesting enough, though, when we coupled it to the BEC, where we saw the high plankton blooms were around the outer perimeter of the plume. These particles are carrying nutrients. These are very fine particles, clay size, micron and submicron, but they, when the quartz crystal is fractured, they have a weakly polar surface. And so the hydrophobic nitrates and organochlorines and all those things, while it's in fresh water, they stick to it. And they are transported to the ocean, riding along on these sediment particles. And then when they meet the ocean in seawater, an electric double layer forms around the particle, and then that ejects the nutrient into the water. So that's how it gets into solution, is through this electric double layer physical chemistry of absorption of nutrients. Next slide. This is the volume scattering function. And you'll notice the highest energy is backscattered at a 0 scattering angle, backscattered to the surface. And as the scattering starts going sideways, the scattered intensity of the light energy in the PAR band declines by several orders of magnitude. Next slide. So these particles, of course, subtle. Now, the most effective backscatters that are responsible for most of the backscattering are, as I said, a micron or less. And so you see from the settling velocities in that first column, and this came from Sverdrup's original book, The Oceans, in 1942, you see that the really fine particles stay in suspension for as long as 87 days. So, and even those that reach 1 micron size still stay in suspension for at least a day. Meanwhile, there's all kinds of ocean turbulence from wind and so on that can keep these things and sustain their settling or prevent creating hindered settling over a long, long period of time. Next slide. And this is evident in this multispectral scanner image after the March storm of 1975. And you see this enormous plume that has basically come off the Santa Clara and Ventura rivers, which have a lot of agriculture. So these kinds of sediment-laden plumes from the rivers are not only extending great distances beyond the coastal zone and out into the central bight, but also a lot of those sediments have got ag runoff components to them, not only nutrients, but also organochlorines and others. So that's the concern. This is missing in the BEC model. There is sediment nutrient flux data, but it doesn't consider sediment transport of absorbed nutrients. And so our concern is that the omission of the particles themselves, the inorganic particles, the omission of backscattering, plus the nutrients that go with a lot of these particles, that's all absent right now in the presently formulated BEC. Next slide. What we did to address the scattering is we got a lot of optic profiles with the attenuation laser devices, but we also used laser particle sizer on the particles that we found. And we found it obeyed a hyperbolic distribution. So it is very feasible to get these, to measure these particle number concentrations in situ. Next slide. Now, my second worry is the way the outfalls have been schematized. And so the basic issue is most of the regional domain model in ROMS is based on a hydrostatic Boosanesque formulation. So this generates various layers between the bottom and the surface of horizontally two-dimensional solutions. It doesn't have any direct vertical dynamics other than through the Boosanesque approximation, where, for example, upwelling along the continental margin is very weak. But it does not account for it cannot account for large vertical velocities directly, like those of a buoyant outfall plume. You might also have problems with upwelling that's occurring not from the curl of the wind stress offshore, but when you get inshore around the submarine canyons, you can also get localized strong upwelling currents from the set down effect of Santa Ana winds blowing offshore. So at any rate, back to the outfall. There are two workarounds that I see attempted by Squirb's variant of ROMS-BEC. And the first workaround is basically to create an embedded source of diluted nutrients from the outfall. And this relies on assuming a mixing volume around the outfall. And this mixing volume is generally fixed, time invariant, and the way it's been formulated is it involves two shape functions. One that defines the horizontal footprint, and the other which defines the vertical distribution. And that vertical distribution of the plume is controlled by two free parameters because it's based on a Gaussian functional derived from a laboratory experiment where essentially a miniature plume was dragged through a tow tank, and it measured the profile of the density profile around that wake of that towed diffuser, miniature diffuser, and it was Gaussian because it wasn't sitting on the bottom. Now, the other concern is we've heard that these free parameters are being used the same free parameters for all the outfalls. So sort of like one size fits all. And yet we know there's tremendous difference in the dilutions of the effluent between the outfalls. They vary with, first of all, the outfall dimensions, the length of the diffuser, the number and diameters of the diffuser, the variable discharge rates of wastewater effluent, and then more strongly, the variations in the temperature salinity profiles. Well, you've got one fixed mixing volume here. And so it's been defined by a vertical Gaussian shape. And so how realistic is that? So if we go to the next slide, Let's just go to the next slide. So here is the mixing volume that's calculated by the latest EPA certified UM3 model. And what you see, we have salinity temperature profiles for an entire year. You see a tremendous variation in the size of these mixing volumes, particularly seasonally. One of the primary reasons is in summer, there is a well-mixed warm surface layer that puts what they call a trapping level on the plume. So the plume doesn't rise as high in the water column before it stops rising and then spreads laterally on the base of the thermocline. So when that happens, you don't get as large a mixing volume. On the other hand, in winter, when the water is more well mixed, often the plume will go all the way to the surface. And in that case, the plume continues to rise and trains more and more seawater, and the dilution and the mixing volume get greater. And the dilution is always going to be proportional to the size of the mixing volume. But note one feature here. Yeah. That first distance where the mixing volume increases while the ejected effluent remains horizontal. So it doesn't start to rise until the mixing volume has reached about 40% of its total size. The reason for this is there's two processes associated with this dilution. Initially, the mixing is created by the high-speed turbulent jets that are ejected from each of the diffuser ports. And so for a while, the momentum flux of the jet, which is controlled by the small turbulent eddies within this turbulent jet, those forces are large. Okay, well, I'm not gonna be confused.
Oh, no, just a laser.
Oh, point, great.
Yes, the red.
Red one, okay. So I'm speaking here at this first point. As the effluent is initially ejected as a high-speed jet, often 3, 4, 5 meters per second, the momentum flux at this moment far exceeds the buoyant stress on this essentially brackish or freshwater effluent. And so it travels horizontally for a while, and as it does, these plumes are expanding in size from each of the diffuser ports, and then they eventually merge. And all the time this is going on, the size of the jet is expanding. And so it's diluting water, but the mechanism of entrainment is from these tiny small eddies in the ejected jet. And those are through turbulent entrainment, causing the initial dilution at this point while it is still a jet. But as these plumes expand and merge, at this point, the momentum of the jet is being diluted through entraining surrounding water. And it reaches a point where the momentum flux of the jet is no longer sufficient to counteract the vertical stress of buoyancy. And at that point, it transitions from being a jet to a plume. And after that, all the rest of this dilution is caused by essentially buoyant expansion of the plume. Buoyant convection is creating the rest of the dilution. So about 40% is done by the turbulence of the jet, which scales as the diameter of the port and the Reynolds number. And then the rest of this rise scales more or less with the Froude. So there's two processes here involved. Next slide. Now, there's another workaround that's been tried, and that is they've created a small inner grid around the outfall, about 3 kilometers by 1.5 kilometers. And this is in this small area, they've essentially substituted the hydrostatic ROMS discretization for non-hydrostatic ROMS discretization. So inside this inner non-hydrostatic ROMS grid, the outfall discharges are represented as buoyant vertical fluxes through a line of grid cells, but these grid cells are above the seabed. And the calculation of dilution results entirely again from the plume expansion driven by buoyancy convection. So this schematization gives me two worries. One, there's no initial dilution from the ground effect by entrainment currents along the seabed while the discharge is still a jet. And then secondly, there's no initial dilution from this turbulent jet aspect of the total dilution process. So my conclusion is the second schematization has to underpredict the dilution, the total dilution. And so that might be back feeding to the BEC model in terms of the nitrate and ammonia concentrations appearing either as a blob or a footprint of nitrate and ammonia, or as essentially just a purely vertically processed, more variable type of plume, but only considering convective forces. Next slide. So here are, while the discharge of fluent, this is a computational fluid dynamics simulation done on the OC sand outfall at the Santa Ana River. And so while the discharge is still jets, notice how the turbulent entrainment by the jet eddies has created these advective cells that are feeding essentially surrounding seawater into the jet and causing that 40% of the total dilution. That's what's missing with the formulation presently that I've seen with non-hydrostatic ROMS, or otherwise known as Croco-NH. Next slide. So I think let's move on, because I know we have done some, for the last several years, some plume tracking using an autonomous underwater vehicle, an IVER 3 to be exact. And we outfitted it with an FDOM sensor using essentially the component of CDOM in the effluent as the tracer. But this is only measuring the portion of CDOM that fluoresces. And here's a plume that we found off the Encina outfall. And we found it about 393 meters down current from the discharge point. And notice that all of the movement is shore parallel. We don't see any cross-shore movement of this plume, neither onshore nor offshore. And the reason we could only find this one patch when the diffuser is this long is that at the last end of the diffuser, this is where the dilution is weakest, because the flow in down the pipeline and through the diffuser is suffering head losses. And out here, the pressure in the pipe that's powering the diffuser jets is trying to push against ambient seawater. And it just doesn't, it's a much lower velocity discharge. So the dilution is always less at the outer end of these diffusers when they are aligned across shore, as this one is. Next slide, please. Yeah, I got it. So, all right, well, let me make the point that in this patch, these are the lowest dilutions we can find, and they're order 10,000. So I suspect that in nature with prototype diffusers, the dilution is much higher than is being assigned in the model. And then finally, I want to make a couple of remarks. Just next slide, please. I have concerns about numerical stability. Now ROMS uses this third order upwind advective scheme with hyperdiffusion to suppress these kinds of numerical instabilities. The most basic is the Courant-Friedrichs-Louis CFL instability, which says that as you go into shallower water and your grid cells get smaller and you try to go to higher resolution, say to resolve a diffuser, you got to run on really short time steps. And this formulation is simply for the barotropic time step. But if you go to the next slide, here's an image from Castori's paper in the Journal of Advances in Modeling Earth Science, 2021. And this is a simulation where they're pressing grid resolution 4 kilometers to 1 kilometer to 300 meters. And what we're seeing here is essentially the vertical fluxes of nitrate. And so you see out here, there's really weak right off of Palos Verdes, and really nothing going on around Catalina. And as you crush down to smaller grid cells at 1 kilometer, you see a little bit of stuff, but nothing too weird. The thing we worry about in this type of numerical instability are banding patterns, spurious banding patterns. So when they go to 300 meters, look west of Catalina, where did all this stuff come? When really there's not much there. And notice how it's got bands to it. So similarly here on the front side of Catalina, all this stuff off of suddenly Palos Verdes when we started with a kind of an area of very low nitrate fluxes. So I worry that there could be some issues still here as you try to start working in the coastal zone. And then finally, with regards to the parameter sweeps, next slide. As Curtis Deutsch had told us, 90 free parameters. Professor McWilliams says, well, going to vary all possible combinations of 90 parameters. It's going to be 90 factorial. Yes, indeed. Well, that's 1.4 times 10 to the 130th power. So clearly you can't vary all the parameters, but certainly you could look at those parameters that are essentially controlling rates of nonlinear functions. And so there's two that come to mind. One is this attenuation of power with water depth, including that, you got to now include scattering. That's an exponential function. And then this Michaelis-Menten half saturation coefficient. Next slide. That too is a highly nonlinear function. And the eccentricity of this distribution is controlled by the half saturation coefficient. This is all done in a laboratory. But what are the temperature effects on this? Are there other constituents in the real ocean that weren't in the laboratory that might affect the absorption rates of nutrients? And then finally, last slide. This question of light limitation versus nutrient limitation, I think it's really, it's a two variable process. But surely if you don't get the light right, you're gonna predict a deeper euphotic zone. And then this is the central issue I think should be investigated with parameter sweeps, homing in on these types of single critical parameters, but don't just vary them one at a time, also vary them in combinations. All right, thank you.
Okay, great. Thank you so much, Scott, for raising all your concerns. And I think I just opened up this. We still have time, right? Yeah. Yeah, so open up the two comments or questions from panelists first, and then we'll see whether the ROMS-BEC community group would like to respond to some of this. Let's Alex, looks like you are ready to.
Well, I just can comment on dynamics, right? So that CFL condition, while you show the barotropic CFL condition, so all I can do is to believe Shepard's papers, right? Shepard in 2015, where he describes vertical advection, how to deal with it. So we understand that barotropic CFL condition would apply to like low resolution models. And then when you go to like 2 kilometer resolutions, the time stepping would be more limited by paraclinic time step. But when you go to like, why would I lecture here? We have Jim here, right?
Yeah,
so,
I agree.
Resolution is probably the vertical advection that limits the time step. And I think since the barotropic and paraclinic parts are split in ROMS, so they have luxury of doing very small barotropic steps. And I don't think that picture that you showed has anything to do with barotropic stabilities. There was like a body of papers like Capia 2008, where they showed that when you cross to sub-kilometer resolution, the adjustment instabilities kick in, and that's probably what we are looking at, right? Yeah. So that they had a scale of about a few kilometers, actually.
Well, there are other possible sources of numerical instability. first of all, this third order upwind or upstream advective with the hyperdiffusion, there's been some concern about that creating spurious mixing, either overestimating or underestimating over highly variable bottom gradients. And the work I saw on the non-hydrostatic ROMs at the OC sand outfall, a flat bottom was assumed, when in fact the Newport Submarine Canyon, this outfall sits right on the rim of the Newport Submarine Canyon. There's very large, bottom gradients there. So another is if you're taking a nested inner model that's in non-hydrostatic discretization, and it's surrounded by, it's embedded inside of this regional hydrostatic model, how is the matching problem solved? You're going from two different domains using two different sets of physics. That could be another source of instability.
I think back to time step issue, and Scott, you and I had a discussion yesterday about
Yeah.
this. I think it's really a miscommunication from my perspective. I think it's really the barotropic time step versus baroclinic time step. I think
Yeah.
Maybe it was not communicated to you, but I think,
Well, that one is baroclinic, the one I showed.
yes, but
Yeah.
what your concern is a barotropic time step. So I
Yeah.
think that's
Yeah.
really
I wasn't-
communication issue.
Well, what I'm saying is the Casori paper said they ran on 30, the James paper said they ran on 30-second time steps. But when you're modeling the OCSD outfall or the big Hyperion outfall, you probably should have ran it around 8-second time steps.
Okay, so I think we would like to move on, maybe.
Well, I want to make a point about that non-hydrostatic. Of course, if you guys want to do non-hydrostatic embedding, we cannot stop you. But I think that's well, it's a 300-meter resolution model, right? So
Yeah.
How big is that jet that you described that becomes a building? Is it like 100 meters?
Well, there's typically like 100 of those ports,
So,
and they're usually no bigger than 6 inches.
yeah, so from the standpoint of 300-meter resolution model, speaking as the engine.
Yeah, I know. They can't resolve it.
It doesn't really matter if it's a jet or the plume. So as soon as that water gets mixed up correctly,
Well,
any of the parameterization schemes that are used there, and I think that's what ROMS we would like to do, kind of mix it on the first time step, and then what we need to assess as soon as you have those beautiful plots for the volume mixing winter versus summer, kind of verify in a 300-meter resolution model. This is like, if you can reproduce that kind of plot and demonstrate that kind of on a bulk scale, the vertical mixing is larger in say in winter compared to summer, right?
Well, again, the total dilution is a function of two disparate scales. The first is on the turbulent scales of these high velocity jets. And the second is on the turbulent scales of convective, a convective plume. Here's a thought. The present high level EPA UM3 model has got all of those physics in one model. So if you want to use that shape function approach, where you're using hydrostatic ROMs everywhere, why not use that EPA model as a calculator for those shape functions? You're much more likely to get the mixing volume right with that approach. And that model runs very fast. So you could embed that model inside of the, perhaps inside the ROMs.
Great, Scott, thank you for that comment or suggestion. I think we'd like to, I know you guys going to, I heard after break, you guys are going to come up, answer some of the questions from yesterday, maybe also from this question, but before, so maybe we should open the floor to maybe a couple more questions from the panelists about maybe other issues that Scott had raised. Looks like Neil, you're ready.
Yeah, I just thought I'd comment on the light scattering issue. Thanks for mentioning it. I think that the scattering issue is a good illustration of the optical differences that commonly occur between coastal waters and ocean waters. I think probably, even if there were no particles in the ocean, there would still be differences in absorption. And I think every
every model system that crosses between the near shore and, you know, the far field blue water oceanography has to contend with this somehow.
Right.
So maybe it's a question to the modeling team. Have you looked at all into, you know, what attenuation parameters to choose to, you know, to deal with that complexity? Or if you can only have the attenuation as you would like it in one domain or another, what did you settle on?
But there's a couple. And so we have actually a slide that we have a slide on it. So what strikes me is that if you would allow us to do that parking lot, then
Yeah, after come back from the break, yes.
Yeah.
is that just, you know, maybe at a high level of response, then to the several sheets. Number one, we had ignored the secret, you know, across the board on both major points Dr. Jenkins made. And then second, that even if there was a basis for it, that we would need to sort of dig in at the scales at which we're modeling, these processes do not factor. And so I think the request of the panel is guide us on what level of detail you want us to respond. And I'll give a couple of examples. I just gave a response. That's one level. That's one bookend.
Okay.
The second level is we've got about 3 or 4 slides to tell you why we disagree. Or do you want us to write a written critique because that takes more time? So don't answer that question right now, but guide us at some point to let us know how you.
Okay, thank you. And Faye, you want to add on to that, or you're okay now?
I'm okay now.
Okay, great. Do you have any quick comments? Margie, do you have any quick comments?
No, just wanted to say I'm here and I'm okay too.
Great, thank you. I think any urgent comments or suggestions? No, so maybe we should move to the break. Yeah.
I am great news. I'm going to break the tape. I apologize for that. But I also understand the women's stress and have problems. And you kind of use the word go to the lobby.
Was that the great news?
We're going to think about teams in a break. So we can finish our late, the next step. It's 10:31. 10:47. We have a full 15 minutes. Bring it down for credit legs, but. Next section. We wanted to create some space for the team, everybody to ask the full range of questions that they wanted to ask of each of the presenters. So what we've done is we've started during the course of the day, we've got last 2 days, we've organized a number of questions that came up different times where we had places where we knew there were going to be questions and that we wanted to have a little additional time to talk through and make sure that we ran it to ground in this setting while we could. So that's what we're going to do over the next hour. So we've got about 7 or 8 questions that we want to get to, but we prioritize it because we don't know how long the conversation is going to go. And again, we want to prioritize the group conversation around these most important questions. So what we've done is we've assigned for the high priority questions. Martha, I thought that maybe we kind of direct you to that slide deck of yours and tell you, hey, maybe you got 3 or 5 or 2 to 3 or 1 to 2 minutes. Give us a little, your take on it, and then we'll turn to the panel so you can have questions. See if there's any questions from the group assembled, maybe online, and try to run that issue to ground until the panel at least is feeling like they've heard the information that they need to hear for their work. Okay, good. So
my suggestion will be we'll keep the questions and also answers during the interactive part of the discussion. All of us try to keep the questions short or comments short.
Yeah. Good point. Move on. Got it.
So we I think the slides 3 through 13 and maybe 3 to 5 minutes on kind of your take on them.
Okay, so first of all, just to make sure that the audience understands, when we were given this agenda item, we didn't, the science team didn't want to just take the time and talk about the things that we wanted to talk about. We wanted to make sure that we focused on the things that the panel wanted to talk about or unanswered questions from the audience. And so what we did was we made a list of potential topics for follow-up and just a slide deck that at this point is pretty uncurated, I'll say. And so where we have some things to say, we already have them in slides. And then I also, on the second point here, there was also topics from the chat and Q&A. And so now that we're interacting with, I've sent that to Gordon and Kevin this morning, and they've prioritized what the panel is going to be talking about. So that's where we're starting. Okay, and so what I just heard that you want to do first is prioritize our response to the critique from Michael Baker. Okay, and so then I think that just a quick sort of recap, that number one, ROMS-BEC is omitting backscattering physics, and the lack of counting a mineral turbidity is causing an overprediction of the phenomena that we're interested in. And the second thing is that the schematic is, I can't even say that, but the plume essentially representation in the model has made some assumptions that also makes it under dilute and therefore over predict. So those are the two things that I already said. We disagree on both accounts, and even if there was an element of validity at the scales that at which we're modeling, that they really do not factor these processes that Dr. Jenkins was alluding to. And so what I have is two slides that just make high-level points. If the panel wants us to go into more detail, we can, and so we'll just let that be the interactive part. So the first criticism is that that BEC omits particle backscattering in its formulation, and that is not correct. It actually doesn't account for that component, and we're prepared to show you exactly how that happens. The second piece is mineral turbidity. This is a follow-up from the conversation that we had with Margie's question yesterday, that river turbidity is only a factor for some rivers less than 10% of the year, more like 3 to 6% of the year, but on a good rain year, let's say healthy 10%, only for some rivers and only at a local scale. And I gave you the rough estimate of on the order of basically a 1 kilometer squared up to 10 kilometers squared in terms of the size of the plume that could limit light limitation. And then finally, if we were wrong about that, don't trust us, look at the model validation. And the model validation, when we look at this question in particular, shows no evidence that the model is over predicting chlorophyll A, which is really what we would want to be able to see. And so look for yourselves, judge that question for yourself. The second thing with respect to the plume parameterization or how we've represented it, I gave you a simple explanation of that and to try to clarify that in our inputs talk, and I can review that with you again. Our understanding is that the criticism really misunderstands fundamentally our methods and our approach to parameterization. I can go back over that if you'd like me to, but even if the criticism was correct, again, we would see that over prediction in ammonium concentration and in chlorophyll A. And again, the model performance shows no evidence that it's over predicting those parameters. So happy to go into more detail. I have a few more slides that does that. I'll let the panel direct us.
Thank you, Martha, for the response to that. I'd like to welcome any comments or follow-up from the panelists on this, and also Margie. Yeah, Neil.
Just a short clarification. When you say that the BEC formulation includes backscattering empirically, which terms and equations or parameter values do you mean?
So I'll pop this up and I'll let my resident expert talk about that. Okay, there we go. Let's start with that. Yes,
microphone. Microphone. Yeah.
Oh, here we go.
Okay, so short answer. We are talking about light attenuation, and I would invite Jim also to say something. So light attenuation accounts for backscattering and absorption. this formulation, and it's the same equation that Dr. Jenkins has shown. The light attenuation coefficient that has been used for that is multiplied by chlorophyll concentration, that reflects from what we learned from optic books, and I'm not optician, but optic specialist, but optic books had clearly identified this or formulated this coefficient to represent not only pigment, like looks like it looks in its equation, but it also represents pigment plus organic matter. So that's how they formulated this coefficient. So that's my short answer to this. So yeah, and that's for what we are. That's for the organic plus pigment part of the backscattering plus absorption.
So we are not including mineral turbidity.
Yes.
And how we're not modeling that, and the reason why is we chose not to. Again, the idea is computation intensive, and you want to be parsimonious in the approach. Do you need to? And at the scales in which we're trying to model the phenomenon, the answer is no. And so it's not to include that mineral turbidity, but it's essentially in accounting, and I don't think the statement that we're not including that gathering physics is entirely.
Can you expand a little bit on the choice you made, right? So what it will take to include that?
I mean, I think what's at issue here, speaking from a research perspective, is having an active particle component of the model, not only to represent the sediment inflow from the rivers, but also the settling and the resuspension and transport, and to try and treat a fair fraction of the biological detritus in terms of particulate form. All of those things are feasible. They're interesting, directions, and yet I do agree with Martha that it's not clear that at this point that's limiting very much the character of the answers we're presenting.
Yeah, that's great. Thank you, Jim. And any other comments? Neil, go ahead, please.
Yeah, as I mentioned, I think everyone with a coastal and open ocean model has some version of this problem, and certainly it's not common at all to include a full optical component or a full particle size spectrum. But one easy trick that might be the next level of empirical function is you let the attenuation coefficient be a function of salinity as a proxy for the entire river plumes. That's a trick we did in the Pacific Northwest, for example.
Yeah,
So you add one more parameter.
But you had lots of fresh water.
True.
Well, and
That's
I
right.
think that
It's slightly rainier there than here.
it's just really helpful to understand this coast and how much fresh water we have coming from this coast and how does that factor. And so there have been some nice studies, and that there is a little bit more detail and slides, but we'll leave it there and let the panel direct us whether or not you want to take that farther.
I think that's a good discussion. Mike's yoke just related? Okay, I know.
Just one quick thing that you can do to see if this is worth worrying about at all is just compare the percent surface irradiance at different depths in the model to the, there's an abundance of measurements from cow coffee. So you can just take a look at that, see if there's any systematic bias near the coast. And if there's not a systematic bias near the coast, then it's probably not worth pursuing ways of fixing the problem.
Okay.
If there's no problem.
That's a great suggestion.
Great, thank you, Mike. And no, I think Margie has her hand up, right? Margie, go ahead, please.
Yeah. So just another, another really easy add is it's really, you don't have to add a full sediment model. You can just add sediment coming in as just, one or two size classes, and it just advects in and sinks out. We generally find the resuspension, of course, it does all these other things like resuspend, but that's really secondary. First of all, it's just coming out. And I personally feel that, I keep going back to these goals of our review, and this doesn't necessarily mean, the lack of this doesn't necessarily mean that the model is not ready for answering management questions, but I feel like this could be on the list of the next steps for improving the model. And just keep going back to climate change. This might be totally fine for everything we've experienced up to now, but who knows what this summer or this fall will bring when suddenly the model is not working, because it doesn't have this, if we have a huge input of sediment suddenly, so. anyway,
Yeah, so
so-
So thank you, and I will say that I really appreciate the incremental suggestions for improvement that sort of scale with effort. And what I want to say is, at the same time, we're modeling anthropogenic nutrients, we're also modeling microplastic. And so everything that you're talking about for that really factors, right? So it depends on the application. And, you know, I think that all of your suggestions make a lot of sense. So thank you.
Great, thank you for the comments on this. Any other questions from the panelists related to other points?
I think the light is important, but it's the regional dependent. We work for San Francisco Bay for multiple projects. It's a similar 18 wastewater treatment plants. Some will release nitrate, some will release ammonia, and we could not get the chlorophyll or productivity or the nutrient dynamics right until we invoke the sediment transfer model for the light. So it's a different settings. And so therefore, I think we need to back to some of the data where and how the sediment loading in this region, you know, is important or is not. So I think a simplified the light parameterization without invoking the sediment dynamics maybe is the way to go. But the second part, I really appreciated some of the slides you presented it, is the light, the nitrogen species respond to light differently. For example, the ammonia can be utilized without the light. They call it a dark ammonia uptake. So, you know, this is a completely different community talk about the nitrogen speciations, and then there's a huge debate. So I talked to Becca yesterday, so I hope you'll pay attention to that kind of development, not only for your region, but for the other regions, San Francisco Bay in particular, the nitrogen species dynamics.
Great, Faye. Thank you, Faye. And maybe in the interest of time, I suggest we move on to the next topic. So Kevin, you have the number 2 there, right?
Yeah, number 2, we're going to go. I think the next priority for the panel was a couple minutes, 2-3 minutes on slide 20. We'll have a conversation on that one.
Okay. What's the topic, just to make sure we're actually really matching up? Was the topic, sediment diagenesis benthic fluxes. Okay. So maybe it's really helpful because we sort of took away our question. I want to make sure it's still your question. So why don't you start by restating what your question is, particularly?
I think during one of the webinars, we had some discussion about whether the benthic of the sediment resuspension and then the remineralization or the are included or considered here. Maybe you can expand a little bit on. Anybody from the panel would like to add on to the question? Okay. Mike, go ahead.
I mean, in addition to just the sediment transport, I like the utilization of oxygen at the sediments and how that impacts the model is definitely something I'm curious about.
Okay. So Faisal, would you like to respond, or Jim?
I would just give one. Sorry.
Yeah, we'll just leave that one down there.
Yes, I have.
That's okay.
Yeah,
I think we're good.
a partial answer to your question about oxygen utilization. That matters for how nitrate has been treated in it's been used for our identification. It's been active. It's active below certain threshold of oxygen, like 5, rarely like rich in this coastal area. And then for any other sediment diagenesis formulation, maybe Jim or Martha can.
Well, I think that again, so I asked, and actually I love sediment diagenesis. It's like my favorite topic. So I asked because I really care about that piece. I understand that the model is not tracking carbon in the sediment, except in the sense, the essence in which it's raining down, and then it can that labile fraction is tracked and essentially some component of it is put back up into the water column as remineralized nutrients. So we're not doing a full diagenesis model tracking all the different pools of carbon. This is refractory, it doesn't, right? So we're not going into a lot of complexity, but the model is responding to the system in terms of its response. What I also heard you say, Mike, was sediment transport. The model does not have sediment transport, so we're not actually looking at the movement of sediment off slope. Jim, correct me if I'm wrong. Again, fun research question that could get pulled in for another application, but here we chose not to represent that. Are you going to disagree with anything I said?
No.
No, good, awesome.
We have done some sediment
Michael.
problems,
Mhm.
but certainly not in these wastewater assessment.
Great. Mike, you would like follow up on that, or you're okay, great. Would you like, should we welcome some questions from the audience if there's?
Yeah, I think we've got
Just
we're off to a really good start. And so I think we should keep going for questions, because I think the questions that came from the audience are kind of embedded.
Mhm.
So I say let's keep them.
Okay, great. Next
great.
topic then.
Yeah, next one, we're gonna move to third priority, and these are just down and near the bottom. Slide 37.
Okay, 37, 38. Okay, Mexico. Okay, all right. So I'll tell you what I heard in terms of the question.
So this is not a question from me. I think it's maybe some of the question from the audience or yeah.
Questions.
Yeah.
It's been a point of confusion that's really just helpful to clarify.
Mhm.
So first of all, I heard a couple different questions in the audience chat, and I'll try to sort of summarize them, and then I'll just look to the audience if I missed anything, call out, because we'll keep going. So Mexico is part of the Southern California Bight. And so the question is, how are we accounting for Mexican sources? Are we, number one, are we accounting for them at all? And if so, how so? And the second piece of this is, what the model is capturing, especially over this period of, the last 20 years, doesn't even come close to accounting for the major infrastructure blowout from the tropical storm or the hurricane, some of the atmospheric rivers, for example, in which now the Tijuana River and its inputs from all the infrastructure failures are going to have an outsized impact on the system. How do we account for that? So that was the second question. Okay, so this is what I want to say. Let me just sort of explain something in maybe 2 slides, and then we can kind of interact with the audience on that third point of, our events, right? So first of all, when you think about, actually, let me start on this slide first, because this is probably an easier way to talk this through. When you think about Mexico, but what I'm showing you, you guys are too far back to see this well. There's a colored watershed, and that's the Tijuana River watershed, 2/3 of which is in Mexico, and it all drains the Tijuana River through the estuary, and that is entering a U.S. Estuary into U.S. coastal waters. Every single piece of what is published that you're reviewing includes that effect. So that includes the major population centers of Tijuana and east. And so we're accounting for that. And I can go into detail for how we're accounting for that, but it's there. What is not accounted for is essentially south of that colored watershed. And it's not that evident from the slide, but essentially, oh, yeah, hold on, sorry. I guess you can see it. I'll walk over and point to it, and then I'll come back.
Something, right? It's pointer.
Yeah, sure.
Make it presentation mode. Right now you're in editing mode.
Yeah, I chose not to because it's gonna be just really hard to skip around, but okay, anyway, all right. So maybe the easiest way to see it, there, great. Okay, so basically, this is the Tijuana River estuary, this is the watershed, and so we're capturing a big portion of what's coming in, including non-point source and point source into the ocean through that representation. What we're not accounting for is essentially south here, and there's one major plant, it's about 50 MGD, million gallons per day, and it's just shy of raw sewage. So that is something that we think is interesting and important. Again, I told you the sort of facts and figures in my first inputs talk. That's 5% of the inputs, bite wide. So maybe not, it's a decimal place on the big picture. But if you move to San Diego, that's like when we start talking about this, it's really important in San Diego. And we recognize that it's like 35%. So that is important to account for that. And so some of the work that we're doing, sorry, I'm trying to get past, geez, why is it doing that? Oh, there we go. Okay, great. So we're doing source attribution scenarios just to look at the sort of, to try to parse out what's all US, what's Mexican coming through Tijuana, and then what's south of the border. And I think that the interesting question there is essentially through any sort of planned infrastructure upgrades, even though the infrastructure literally just blew out, they are planning on investing something like $130 million in Mexican infrastructure to correct this enormous pollution problem, more from the fecal indicator sort of issue that's been impacting that part of the coast. So at any rate, we are doing some additional analysis to include that, but it hasn't been a routine part of our workflow.
But that's already included in the budgets or in the numbers you provided or in the papers.
Yeah, so what's routinely included is the Tijuana River estuary, which is the major part of that.
Okay, but that not the corner part.
Yeah, that sort of south of the border is not included. It's about 50 MGD. So it's about 5% bite wide, but then it becomes pretty significant if you're just looking at San Diego. Does that help?
Okay,
great.
Thank you.
So, yes. No, let's make it interactive. That's great.
Okay. Microphone for the.
Let me just pull this. Oh, there you go. Excellent.
Thanks. Thank you, Martha. And yeah, I just wanted to ask a follow-up question because I'm Stephanie Jager, City of San Diego. So, and in the ocean operations group, so I'm just out at sea a lot and, you know, witness that. And so, as you mentioned, that those transboundary inputs, the inputs from Mexico, it's definitely been a huge issue, especially for bacteria on the beaches, but also since a lot of this is the untreated sewage, even offshore, you know, we smell it. It smells like a toilet sampling offshore very frequently. So just to mention, yeah, I just wanted to help understand those impacts. And part of my question too is just to how do we quantify that? First, sometimes these inputs, you know, they're not always reported, you know, it's from the US side of things. I feel like we have more data on our, you know, our effluent, we have better data on all that. Some of this data is more limited that we have. And how do we quantify and account for that just to help get us to more realistic scenarios, including all this raw sewage, for example, and also, you know, as you know, it's at the surface, you know, it's easier to interact with, you know, phytoplankton, other things right there, because it's right there at the surface coming right in. So just wondered about that, because that's certainly an important topic for San Diego.
Hi, everyone. I happen to work for 22 years in San Diego. And my graduate work was actually done on the Tijuana watershed. Could we put the map back up, please? Thank you. So I think it's important for the panel to recognize that right at the US-Mexico border, there are two wastewater treatment facilities side by side. One of them discharged to the ocean, and that's capturing wastewater that's actually draining from the urban Tijuana area. And that's the plan that's been in hot debate as far as the responsibility of the US International Boundary and Water Commission to fix and improve. There's another wastewater treatment plan at Punta Bandera that's a little south. That's the one that Martha, you spoke of. That has not been functioning for well over a decade. And that's the one that's spewing out raw sewage. So what you're seeing right at the US-Mexico border are two different things. That outfall I just spoke of the International Wastewater Treatment Plan is only about 2.5 miles long. And that plume, when interacting with the discharge from the Tijuana River system travels northwards along the Silver Strand. And that's why you hear about Hotel Coronado being impacted. So you can see on satellite a lot of sedimentation, indicators. And then there's the additional input of the treatment plant that's responsibility of the government of Mexico down in Punta Bandera, inside the Mexican borders. So we actually have several problems happening in that area. So when you are modeling and accounting for discrete sources, I think it's important for us to understand whether or not separate attribution need to be made for those sources, because the interventions could be very different. One is within the control of the US government. The other is now in the hands of the Mexican military, as announced last week. Punta Bandera now is the hands of the Mexican military. So just want you to be aware of that.
Now with speaking, I was thinking, so the Mexican, the input from the Mexico, they're there. I guess maybe in your response to the comments, you could also speak about how that will affect. So the question, for you guys, I guess, is how much the US input is affecting the ecosystem or affecting the coastal environment. So how will that affect your ability using this model to answer that particular question?
So, I mean, I think that to maybe the high level response is, what is the question that we're trying to answer? If we're trying to answer that sort of first management question that was in Christina's presentation yesterday, sort of writ large, what is the sort of net anthropogenic effect of nutrients? Then you could ask yourself if ignoring 5% is going to change your answer. It certainly matters for San Diego. So I think that the panel can comment on that, but our general sense is that we did the best we could to account for it. And yes, we can go farther, of course. So the second piece of that then is, can we start to really dig into the San Diego region and sort of pull it apart? And then really, if the model starts to be more into sort of decision support mode, then how can it help us there? And I think there's quite a bit more that we can do. And to Lon's point, to go farther, to pull things apart, right? So I'm then sort of thinking about the model in sort of decision support mode, and that we would build in the capabilities to use it in that way in order for it to be commensurate with the job that it's being expected to do. And so I want to make sure that we're sort of clear about that mismatch, because, for example, let's just be honest, right now, the model does not it's really responding most to the inorganic nutrients in wastewater, whether it be raw sewage or treated. It's not really responding to that plume of raw solids that, when we got our tour yesterday, that was all being screened out. That will be settling in the sediments. That's going to have an oxygen demand in the more immediate place of the plume. There's a lot of other factors that the model's not including. So the way in which we think about the model in decision support mode is that we have to have the capabilities to answer the question at the right scale in order to really be informative. And so those are the types of investments that would have to be made ultimately to use the model further in that mode.
A quick clarification question on that is that the Mexican input or the outfall, is it within your model domain or it's outside of the model domain?
It's actually inside of our model domain.
Okay, but it's not right now. There's no input at that side.
No, there's not.
Okay, got it. Thank you. All right. Any other comment on this? A question on this from the panel? No? Okay, maybe we can move on to the next one. Kevin?
Yes, we're going to go to the priority 4 question, which is on slide 14.
Okay. I feel like this is a game show. I don't remember.
Right, it does feel like that.
Okay, great. Good. All right.
I don't remember where this question from. Maybe it's from the audience.
No, so it was actually sort of a follow-up to Alex's. I think it was a written question or his email question about
yes.
performance assessment of high frequency transport and circulation. And we just didn't want to let it go. So we sort of we asked Jim and Jim gave us Jim is always very pithy. So Jim gave us a pithy response. But ultimately, we just thought, okay, let's talk about that and make sure that you're satisfied with the level or the depth of the answer that you're being given.
Well, I think what I really wanted to see here, well, actually, we saw like that time series for temperature at 90 minutes was convincing, and we talk more. I think will be more convincing for actually, not for me, but for stakeholders, users. If you compare to dissolved oxygen time series, because they are available somewhere, right? It's not just like a coffee ship-based data, right? There's like a tremendous amount of mooring data either collected by scripts as a part of research projects or regional associations, right? The data are, I believe, data are out there. Like 20 years ago, we would look at dissolved oxygen high resolution time series of, like, say, of Oregon, right? And PCO2 as well, right? It feels like kind of comparing to that data would be tremendous help to you guys, right? First of all, in communicating your science to the stakeholders. That was kind of, that's why I kind of brought up that I was trying to look for that kind of information. They just asked like where to find it. So basically that's it. Yeah, and I think whether we really need to focus on high frequency. I mean, high frequency means like daily and like on a scale of a few days, or seasonals and faster than seasonal, daily, and internal ties maybe as well. So it partly depends on what the management questions are, right? Yeah, that's all I want to say.
So thanks, and I think that, the team is sort of communicating that we're definitely acknowledging that. And if you remember the gradients slide that Faisal said that there were 5 or 6 gradients that we looked at. The last one was events, which is a sort of like our sort of code for time series, right? And I think that if you look at the paper, that's what's missing. And the reason is because we did 1997 to 2000. And so, most of our modern time series, they're maybe a little bit ahead of us in Oregon, but, they really start, I think that Faisal's had our longest records for about 10 years. And so in this iteration of the model validation, what we've been trying to do is work on that. And so we're in the middle of those workflows. He showed you temperature. We didn't mean to communicate that we're stopping at temperature. We would just love for the panel to sort of give us some recommendations about what you think would be really useful, and also try to prioritize it, because we can do a lot of stuff, and it's just sort of time and people, right? So
yeah,
go ahead.
And again, it depends on what the focus is. So we discussed Tijuana River and
right,
the river plume dynamics here. So basically, I think the 300-meter resolution, you may hope that you resolve some of the. Those rivers are pretty small, right? You really need to go sub-kilometer resolution to get any kind of faithful representation of the plumes that like to go out and turn to the right, unless there is wind. So yeah, so basically, and there are data out there, like glider data, and that kind of that all can be interesting to see, right? Yeah.
Well, open to suggestions. I think that's the bottom line.
I guess I want to say something about, I almost forget, but I think I know. The high frequency variability we've been talking about, I think it's a lot, as you said, it's a lot about the events or the major events, storms, and can you maybe comment a little bit on, so the outflow flow is more steady, right? So longer term. So the impact we are looking at, overall impact we're looking at is more longer term. This is my understanding. And so maybe you can comment on how maybe you already said it, but I just want, or think I would like to hear it again, how the short-term events will impact the overall impact, the influence of the outflow on the coastal system.
So I think the answer is, if we're looking at outcomes of oxygen and pH, that, the short-term events are only important in their cumulative sum. So if you're getting, over the overall sort of seasonal to annual and interannual productivity, the right scale, it's, I would probably say the spatial fidelity is an important factor in that. So I think that if we care about oxygen and pH, those short-term events are less important. If we're modeling toxic HABs, then that proposition really switches and we really care about the events and what's affecting and how we're getting those events correct. So I would invite my colleagues to correct that, any of my statements if you think I'm wrong. Did that answer your question?
Yes, yeah.
Yeah.
Thank you.
I mean, just sort of a generic remark. If events are a concern, if the Tijuana unincluded plume is a concern, then one can certainly do a particular, short time focused assessment of a nested response to that and, at least have the example in hand, even if it's not part of the routine operational model.
Thank you. Margie, do you have any, I know we've been ignoring you. Do you have any comments on anything on the stuff, topics we have discussed?
Nothing additional, I don't think. Thank you.
Right. Any other?
I guess I'll just say one thing that I feel like, Martha, it's still kind of a research question. I kind of, obviously it's more important for the halves, but I wonder, yeah, I feel like we don't quite know whether how much these short-term events can, if it brings in organic matter, then it can stay around a while and remineralize slower and longer. But yeah, I appreciate your point.
Yeah, no, I think it's a fair question, Margie, and I think that ultimately because the modelers have made some decisions about what to care about. And so what we're doing is trying to be guided by our validation to tell us whether or not we're missing something. And you heard that loop in Faisal's presentation, in which we basically did the first round and then said, okay, look across the coast, how are we doing? What are we missing? And then if we make corrections, does it fix it? And if we've made all the corrections that we think of, and we're still missing a big piece, then that tells us that our way of thinking about that is wrong. And so it is fundamentally a science and a research exercise that we're doing, but it has important management implications.
Right. Yeah.
So you mentioned HABs. I think we're talking about here is the overall ocean health, whether it's from the coastal eutrophication and from the rivers or the outfalls, or the ocean acidification pH or the oxygen. It seems we need to consider this all together instead of piece by piece. For example, the heat waves and cause the stratification, and then that potentially lead into at the bottom hypoxia events. So therefore, I appreciate the focus on pH and oxygen, but as you know, this HABs not all necessarily produce the toxic. So the diatom blooms potentially, and then through the mineralization, and then can cause a hypoxia when they sink. So therefore, we need to somehow, for the next phase or whatever you do in your operation, maybe we should consider this together.
We're trying to bring all pieces together. Some are lagging, but we're looking at the three legs of the stool, which is oxygen, pH, and toxic HABs. Maybe there's a fourth one there, which is light limitation for SAB. But they're not all being brought together all at once. And so I appreciate.
What is SAV?
Submerged aquatic vegetation, like seagrass or kelp.
Okay,
So
good,
we're
thanks.
just trying to look comprehensively at those pieces. But you're seeing what we've published so far, that we're basically feeling that this is the credible piece of work that we have so far.
Good. Got it. Thanks. Maybe we can move on to the next topic.
24 to 31, a follow-up discussion on BEC parameterization and sensitivity analysis.
Okay. Which one was that?
24.
there we go. Okay, so I don't know if we have a whole lot more to say than what we've already said, because, you know, and by the way, thank you, Andy. That was great to kind of revisit that with the panel. I'll let the panel ask any additional questions. We don't have further remarks other than if you would like us to give you a more detailed response, we require the other members of our team to do that.
I think the parameterizations, we have had a lot of discussions about it. I guess my suggestion would be maybe we can talk a little bit about sensitivity analysis. I think in one of the webinars we mentioned a little bit, but very briefly, or maybe you guys want to comment or just on how, you know, whether you have done some, you know, sensitivity analysis and what maybe not, or what, why, or just I don't know whether any of the panelists would like to add on to that.
Sorry.
Neil, you can go ahead. You know, frame the question. Yeah.
Yeah, I think both formally and informally, we've had a lot of discussions about sensitivity analysis in general. There's one issue that hasn't come up today that I did want to raise, which is, well, first of all, I think that until you've done a really thorough, multivariate, multi-scale performance assessment against data, there's not much point doing a detailed sensitivity analysis. Once you have this really broad suite of comparisons with observations that you can do, well, that does constrain the model quite well, but then you could actually push it further. And the concern, I think, is that not that there is some gross error in primary production alone, for example, because you would notice in terms of chlorophyll, but compensating errors. Because you know, Mike was saying that you could broadly classify these things into things that speed up the turnover, things that slow it down. And, you know, if you take all the criticisms we heard earlier together, well, you know, it's by those mechanisms or some other, what if primary production is too high and export is too high? You could get chlorophyll right, you could get the drawdown of nutrients right, but the overall time scale of the, you know, generation of hypoxia would be wrong. And then that would put maybe the right oxygen impact in the wrong place, that kind of thing. So do you have any comments on, you know, a feasible approach to sensitivity analysis that could start to address those things or add some confidence?
Just a platitude. When you see something you don't like, you check its sensitivities. I mean, I don't think it is feasible to systematically do this because of the 90 factorial remark that was repeated. It's rarely done in, for example, global climate modeling, on which the future of civilization depends. As Faye remarked, the best exposure of sensitivities is often the confrontation of different models that are purporting to do the same thing. We're still at a pretty primitive stage of that here. It certainly could be done more.
So Mike, would you like to follow up on this? We had extensive discussion last night over dinner about this. I think you were thinking about, you know, even though we don't have ensemble biochemical models here, maybe we can some sort of create some ensemble here.
Yeah, so, I mean, I completely agree that there's no way to do a full multifactorial analysis, but we can pick certain parameters that, as Neil was saying, are likely to speed up the turnover time, and other parameters that are likely to slow down the turnover time, and just have some targeted parameters that we look at, maybe modifying a couple of them at a time. But then really focus on some of the model outputs that are most relevant to the management questions, because a lot of the analysis of the sensitivity of the model has been done basically in the way that I would do it, of looking at primary productivity which is interesting from a broad scientific perspective, but not as narrowly focused as you want for the management questions. So it might be worth thinking about, well, what targeted parameters could we change? And then what do we really need to validate to see how does this change what's most relevant to the hypoxia question or the ocean acidification question? How can we determine if that's important in driving our results?
Well, and I appreciate that thought process, because I think the problem, not the problem, maybe why, if you looked at our uncertainty analysis work plan, it was floated out there to you guys, it wasn't, sensitivity analysis wasn't prioritized because it didn't drive a specific decision about what to do about it, right? So, okay, so yeah, it's, the model is, or the outputs are, sensitive to this. So what it would be really helpful to do is do the sensitivity analysis that's directly, coupled with observations of rates. So for example, like we talked about carbon fluxes, that's a perfect example of, hey, if the model is really sensitive to essentially some of the processes that Andy was pointing to, and that, that's really sort of management relevant, then that should be coupled with, observations or comparisons with the observations of whether or not we're constraining that within a range that is reasonable, because we can, again, I think that, I would go back and pull out that particular slide that Chris Edwards had when he gave us this talk on uncertainty. And he said, if you've got this many parameters in your model, you can have almost an infinite number of correct solutions, right? And so, but you really want to constrain it with what is sort of ecologically relevant for us. And so that's what we really want to know. And so any targeted recommendations for how to couple sensitivity analysis with the appropriate rate measurements or things that really help us ground truth that and give us a practical course would be really appreciated. And the other, I think I'm sorry, just one more tiny thing, that we have trade-offs on scales, because Faisal would be the first person to tell you that if you did sensitivity analysis rapidly at one kilometer, you may not be getting the exact same information that you would be getting if you did it 300 meters because of vertical fluxes, right? So I just want you to be attentive to scale when you make those recommendations.
So if I may, I agree with Mike and Neil. This really endless in terms of the parameterization testing, all that. The first day I asked the management questions, you gave me 3, right? So I want more, right? So therefore, I think doing this model sensitivity studies or improve the model performance, we really need to put this 3 management questions and more specific. For example, what are the effects of anthropogenic nutrients on seawater chemistry? This is too broad. I will ask where, when, and how. If you break it down to those 3 questions, where, when, and how, we may use our models much focused way.
That's a lovely suggestion. I agree.
Yeah, so let's move on to the next one.
I won't get to all these questions. Let's do it. Okay, so the next group is slides 22 to 23, and that's questions about appropriate time scales to compare vertical ratings.
Yeah, so we spent a little time on this already this morning. It was mostly, I think this was another one of great, like Stephanie has a lot of great questions. Oh, there's someone else who wants to jump in.
Microphone. Where is it?
Who's got the microphone?
Hi, everyone. I'm Shelley Walther, LA County Sanitation District environmental scientist. I've been working on this for several years, and appreciate this discussion about sensitivity analysis. Curtis Deutsch did a number of them following up on Moore's work. I talked to Martha about this several months ago. She said the bulk of them were done by Keith Moore and that you have them, and that Curtis Deutsch had done more and you don't have those. And he presented one slide and he said that more was coming. We've never seen any of that. All of this discussion of future sensitivity analysis work? What about what's already been done? Would that be informative? And also just model output to help inform this?
So one minor correction, but I believe your question is to the panel. So let me just say, so just for clarity with the audience, what's been done. So in the early model development, Curtis did sensitivity analysis. And then in the final sort of publication stage, that never rose to the level in which they chose not to publish it. So we have, I think, the output files of the work that was done by Curtis. So we have that. We could make a list of what they did. And so the question that Shelley is asking you is whether or not that's worthwhile mining that to present to you or something.
Actually, I want to ask, return the question to you. So
Yes.
since Curtis has done all this sensitivity analysis, assume those analysis or exercises have guided him or the whole team on the choices of the parameters or uncertainty, the quantification of the uncertainties, how that.
I mean, it was said earlier that basically the parameters are those that Keith Moore figured out early in the 2000s. That's not true. They've been explored substantially by really everyone who does a new problem. I mean, Curtis has done a fair bit. Daniele Bianchi has done a fair bit. The way it happens is, and I think maybe Mike's remark about, the way I do it, reflects this reality. You have a bunch of comparison fields. In this case, it would be basically nitrogen, oxygen, chlorophyll that are your sort of standard biogeochemical cycle fields. And you wander semi-randomly through your parameters. You identify the ones that have the most leverage. Curtis gave a list when he spoke in the webinar of the ones that he had found. But it's not really a documented trail. And it's not really an orderly trail because you're confronting the 90 factorial. And it's I think the right response here, if something needs to be documented because there's a particular issue, fine, document. But really it's a living model and you keep doing, new problems and new data sets and you keep assessing parameter choices.
Yeah, so at least, so what you are saying is that even though there is no robust quantification or being used to guide the choice of the parameter, but it is being used over time, right? So that
it has,
yeah.
but I don't know how you would make a meaningful record of it unless you set about to do it more systematically in order to present the system and its results.
Great.
Is that sort of what you meant about how you do it? Yeah.
Guys.
Well, this won't be the immediate request for action, but as soon as we brainstorm here, like, okay, you have a system with 90 degrees of freedom, right? And you have a bunch of data and try to tune those data to tune those 90 parameters to fit the data. I think this is a perfect setup for the data simulation project, right? All you need to do is find a tangent linear joint of ROMs and add a tangent linear joint of your biological model with respect to the parameters, not the initial conditions of forcing, but with respect to parameters. And actually, from the standpoint of data simulation, this is rather simple setup. It's only 90 degrees of freedom. You have more data than you have unknowns. So something like a joint method would give you something. I'm not sure if it will give you something useful or something not useful, and probably some of the parameters that you don't believe can be constrained by the data, you just don't touch them anyway, and you set up the error bars on it in the framework of data simulation. But I would tend to think that somebody has done it in the past for some other models, maybe. So I don't know. But I think
so can I just say that we did just that with this model and published it in 2006, and it was a nightmare. And we do not want to do it again. It was 1D, of course, back then, but we used the adjoint method, just as you said, took out variables that were, but there's so many correlated parameters. It's a nightmare.
Yes, but the question is like how you treat your data, right? And what you match your data to, like you do match them point by point, So it's a very random turbulent field. So, but if you really treat the data as like averages over basin and compare them, really kind of try to constrain the model that way. So probably that's not the. Yeah, I know it. Well, I hear it was a nightmare. I believe it might be. Data simulation always like a not very pleasant exercise unless you really like it. So, but I don't think it's like. Hopefully it's not the last word, right? Somebody else will have to try it.
You are methodologically correct, and we're looking for volunteers.
I'll have to retire first and then submit.
One very quick thing to clarify about this discussion. Am I right that the existing sensitivity analysis by Moore and by Curtis is on a very different scale? That Curtis's was at the scale of the entire California current, not the bite in particular.
Not quite sure, but certainly the California current scale was paid attention to more than the local scale. But the principle we're trying to adhere to is you don't go around adjusting the parameters just because you change your region. You're looking for something that is quasi-universal, recognizing that quasi is big.
Yeah. Okay. Thanks.
It's time to go to lunch right
Okay.
now. I think because
Mhm.
scheduled relatively efficient. So we're a few minutes over. What I'd like to suggest is that a couple things. First, if you haven't already signed in, please take the time to walk over to the table, sign in so that we have a record of you being here.
So even if we already.
Yeah,
signed
no,
in
if you signed in yesterday, please do sign in again today.
Okay.
Yeah, thank you. I appreciate that clarification too. So let's, sign in. Then we'll start our public comment session. Originally, we were going to start it at noon. We'll start that at 12:30. That'll give us time to get through lunch. The lunch just arrived. We can cycle through and get through lunch. We've got a number of people that have signed up for public comments, and then I'll tell people who are listening online and remind anybody who's here that we have an hour for public comments. It'll start at 12:30. If you'd use the Q&A function, let us know that you'd like to make a public comment and whether you'd like me to read your public comment into the record, or if you'd like to make your public comment, we'll fit you into the schedule. With that.
Is that a public comment part inactive or it's just a?
No, we're going to listen. That's going to be a listening part. And I think that you may have a question or two of some of the presenters, and I think that we would want to encourage that. So interactive that, yes. I think my first question, my first response was no, but I think realistically, we want it to be as interactive as the panel needs it to be valuable. Okay. And with that, let's go to lunch, and it's in back. Do we put it in the hallway?
No, I'll go through the fan.
Okay, good. Let's grab some lunch and we'll reconvene at 12:30. Okay, I want to welcome everybody back to our next session here and send some appreciation to my staff for a wonderful lunch. It was well timed, and thanks for healthy energy. Okay, so we have scheduled now about an hour for public comments, and we have 6 people who are going to make comments for us today. A couple of them are online, and we're going to start with them. What I'd like to do is ask for everyone who's either online or if you're here in the room, just to start with your name and your affiliation, so that we can make sure that we know who you are and how you fit into our group. And then I think we have probably is 5 minutes or so each for comments. So we would love to hear what your perspectives are. There may be some interactivity with the panel on some of the questions on points that might be raised, and we'd love to have that communication and interaction with the panel and the commenters. So with that introduction and a thank you to everybody to just being patient and open as we work through kind of the technical and offsite folks here. Want to be patient here. So with that introduction, I want to introduce our first commenter, who is Karen Mogus of the State Water Board. Karen, thank you for commenting.
Thanks, Kevin. Yeah, I'm Karen Mogus. I'm Deputy Director for the Division of Water Quality at the State Water Board, and I also am one of the members of the steering committee that is guiding the process along with NWRI and CASA for this review. I apologize that I cannot be there in person. I work for the state of California, who has a budget crisis going on right now. So you get me from home today. Really appreciate the opportunity to join remotely, though, and I've followed the conversation and really have enjoyed learning along with the rest of the group. I'll keep my comments brief. The Water Board really welcomes the opportunity to review the scientific basis of all of our management actions. In fact, we're required to peer review the scientific basis for the proposals that we put forth for regulations and other permitting activities. So I really appreciate this opportunity and that NWRI is running this process and being so thorough. I also appreciate all of the panelists. We wrestled with both getting folks on the list, but then also getting I think we've assembled a great group. And so I really appreciate your time and your thoughtful observations and constructive recommendations so far. I look forward to hearing more as this review continues on. Wish I could be a fly on the wall at your dinner meetings and whatnot. So what we really need from you is a review of what is your review is to know if you have concerns about the overall conclusions that are presented on acidification, dissolved oxygen, or other parameters that the model is modeling. So what we need to know is, will the model improvements completely reverse those conclusions or just alter the impacts around the edges? Our main question, I think we're really concerned about the conclusions where the anthropogenic impacts, anthropogenic nutrients impact a quarter of the bite for 3 months out of the year. That's, to us, of grave concern, and we need to do something about it. Our main question for the model, and now in the future for future scenarios to run, is what effect will management of nutrient discharges, including nitrogen treatment and water recycling, have on eutrophication outcomes in the bite and eventually across the entire California coast? What are the biological effects of nutrient reductions in large POTWs only compared to all POTWs, large and small? So is there a process by which we should be prioritizing these improvements? What are the biological effects of planned nutrient reductions that are already moving forward based on current infrastructure plans for large POTWs in the Southern California Bight? We really want to be able to use this information to identify key regulatory actions we can take to reduce the impacts from discharges and be able to measure the improvements that result from those actions. We see that as the primary purpose of the model moving forward is, if we take these actions, are we seeing improvements, and what are those improvements, or should we be doing more? And this also includes prioritizing the state's investments in infrastructure improvements to improve water quality. So it's not just in the permitting process, it's also investing funds through our state revolving fund and other grant programs to make these improvements. So we have sticks, but we also have some carrots to apply to this. So with that, those are my comments. Again, thank you for your thoughtful input, and I look forward to more discussion and happy to answer any questions you may have.
Thank you, Karen. I'm looking at Gordon. Gordon, members of the panel, any questions for Karen? Neil, please.
Hi, Karen. Thanks for that. That's clarifying. One question for you. I think Martha, in her first presentation yesterday, gave the context as interest in nutrient reduction as a means of counteracting effects of climate change. So to what extent is the climate change context, meaning some kind of comparison between climate impacts and the effect of nutrients, important context for the Water Board as you think about this work?
Well, it's certainly important context for us. We have a climate change resolution that our board adopted in 2017 that talks about the kinds of things that we can do in our regulatory programs to advance the assessment of impacts and ability to reduce those impacts from climate change. So it's of high interest to us. Our knobs that we can turn all relate to controlling discharges. So for us, it's about reducing nutrients from sources, both POTWs, point sources, and non-point sources. I appreciated the questions around the sources from the non-point source contributions to the problems yesterday. I think Margie brought that up. For us, it's how do we use our tools, whether that be, again, our regulatory tools, our sticks, or our carrots, to encourage addressing discharges that exacerbate the impacts from climate change. Did I answer your question? Ish?
Maybe this is impossible to answer, but if the climate were not changing, would you be equally concerned about these impacts on the bite?
Oh, absolutely.
Okay.
Yeah, I think the reason we have this information was because we were trying to tease out, along with the Ocean Protection Council, the possible anthropogenic sources. And in fact, I think John Bishop at one of the earlier webinars said we had no confidence at all that anthropogenic sources of nutrients were going to be anything compared to natural, ocean upwelling and other climate change impacts. And so we were surprised as anybody else at these findings. But yeah, for us, it's of huge concern for the environment. We're here to protect water quality in the environment. And so, yes, these results would have been just as concerning without climate change. I don't know that we would have gone down the path without climate change being the driver, though.
Good. If there's any other questions?
Okay, we'll move to the next commenter. Yeah, let's do that. Okay, next up is to comment is David Gibson, who's with the Regional Water Quality Control Board in San Diego County and also a member of the steering committee. David, take it away.
Thank you very much. Thank you very much to the members of the panel and to the National Water Research Institute for bringing us all together. This is really an extremely important moment. And like Karen, I very much regret working for a state that finds itself short of cash right now. And unfortunately, the border issues, which were discussed earlier, have intruded upon my schedule as well. So would have been problematic for me to attend. But I'm really glad to be here today and speaking with you. I'd also like to extend my thanks at this time to my colleagues on the steering committee for working together so effectively to bring you what I hope are the correct questions and for your engagement that we've had for the last 2 days. I'll also like to just say that selfishly, as a SQUIRP commissioner, I'm very proud of our scientists for yet again leading the way on the science and engaging with you, I hope effectively, yesterday and today. The intersection of science and regulation is a key question for our boards. I believe you may know that the state of California is divided up into 9 regions based on watershed boundaries. To administer the Clean Water Act and the state's Porter Cologne Water Quality Control Act. 6 of those regions are on the coast, of course, and the State Water Board administers the ocean plan rather for ocean discharges. Each of the regions has a basin plan for watershed sources. The board members are appointed by the governor and confirmed by the Senate, and their challenge is to address and to thread the needle, as it were, policy in terms of being reasonable and effective and protective of waters. And so your question a moment ago is really pertinent. Yes, climate change is a key factor, but our challenge is to be reasonable and protective in protection of the waters and to demonstrate through data and through science that the waters are in fact being protected. And in this forum and this panel is extremely important, I think, at this moment to address ocean acidification, harmful algal blooms in the context of climate change and in the Southern California bight generally. On behalf of the San Diego Regional Water Quality Control Board, I share Karen Mogus's concerns, very artfully expressed a few moments ago. I can hardly add to them, except to say that in the permitting realm, which the water boards do, the regional boards, one of the key questions for an NPDES permit is to ensure we're asking the right questions of our dischargers in regulating ocean discharges. And I'm hoping that coming out of this review panel on this key question, we may learn how to improve those and refine those, so we're collecting data that may be needed to fill gaps in terms of model improvement and so on. I would also just like to add that on the border issues, for context, these are not new issues, and nor are these new discharges. The current issues and changes in pathways of sewage flows from the coast to the river and the ocean have been ongoing for many decades. And I believe that the South Bay Ocean outfall monitoring done by the city of San Diego for the International Boundary and Water Commission and the city are properly addressed by SQUIRP. And I hope that if we need to, we can make adjustments in the monitoring that takes place there on the coast. There was a lot of discussion about sewage discharges south of the border. Again, these have been extant for a very long time and are a significant source of nutrients, and that watershed is a significant source of sediment, an issue that came up yesterday, as I recall. So I appreciate your attention to this, and we look forward to your review and findings. And like Karen, I've learned a lot from the last 2 days, and I wish I could be on that fly on that wall. And I'd be very happy to address any questions that you may have. Thank you very much.
Thank you, Dave. Mr. Chair?
Okay, questions? It's open to the panel. Anybody has any comments, questions? Just raise your hand. Margie? Nope. Okay. Thank you, David, very much for
Thank you.
Yeah.
Okay, next, our next commenter is Lon Wyborg. She's with the Orange County Sanitation District, and she's a SQUIRP commissioner as well, and a member of the project steering committee. And so the folks who are here, we're going to have them join us at the podium.
Yes, so you don't have to turn all the way to the back of the room. So thank you. Good afternoon, everyone. I'm actually going to invite Steve Weisberg to come up and join us. I've had the pleasure and honor of serving on the steering committee to support the selection of this independent review panel. And Steve has served admirably as our science advisor along with Kristen Davis, and I don't think she's here today. So Steve, if you want to grab a seat, that would be awesome. I happen to serve as a commissioner at SQUIRP as well. OC San is a founding member of SQUIRP, one of the big four that started this fabulous organization that looks into environmental issues and makes sure that we're working together to protect the environment for many years now. How old is SQUIRP? 55 years. So our perspective on this effort actually largely resemble what Karen and Dave have said. We're an environmental protection public health agency, right? Without us, you can practically state that civilization wouldn't be as we know it today. And on your tour yesterday, I think you can imagine how we've not rested on our laurels, although whatever it is that we do at our treatment plan needs to last, needs to work. Failure is not an option. As you saw, when we make big investments, we attempt to capture multiple benefits, and we try to make no regret decision. And how do we do that? We try to define the problem in a way that's measurable, both quoting Faye, if I may, the when, what, and why, right? And this way we have the ability to enact interventions that can result in measurable outcomes. And I'm echoing Karen here. So our ask of you is that we understand there is an early indication of a seasonal phenomenon that's occurring off our coast. And there's some data that's been used effectively by the SQUIRP's team to generate some of these projections. I'm here to reflect to you that the POTW community that I represent, we are standing by to provide the resources necessary to follow your recommendations. What we would like to ask is that, as you saw yesterday, at $200 million of CIP projects a year at OCSAN, we don't make those decisions lightly. And we have stepwise and often iterative decision-making along the way. As you deliberate what it would take for you to help us make a no-regret decision on intervention, treatment that you identify as potentially effective, we would ask you to break them into serviceable pieces where actions in the early stages could inform later stage actions so that we can measure the outcome along the way. And with that shameless ask, what I'm also going to ask, follow on to that, is for you to stay available to us as a group, if you're willing. I will take a moment here and ask Steve to provide his input, because I think his team has done a marvelous job of working with the dischargers. And they've done a great job of letting us know that this is a research model. Turning into something that's operational has its challenges. And so in paying attention to your questions throughout the last couple of days, we recognize that you appreciate that fact. And we would love for your recommendations to identify how we can get from research to the initial stages of application, and eventually where we all need to get to, which is finding the right intervention. Perhaps the submerged aquatic vegetation that was mentioned earlier could be one of the solutions rather than action at the POTW. These things could happen in parallel. There's no reason why we have to just choose one thing. But once we identify the problem, its persistence, consistency, and magnitude, we need to find actions that result in outcome that will satisfy really our bosses, the ratepayers in the state of California. We're running a deficit at the moment. We can't afford to take gamble with major projects that cost in the billions. So Steve, with that, would you like to say a few words?
Sure.
Thank you.
So Lon asked me to elaborate a little bit, since as she said, SQUIRP is, actually I should have introduced myself. I'm Steve Weisberg. I'm the executive director at SQUIRP. And so I've obviously been involved with this for a very long time. SQUIRP is a consortium, a research consortium that's formed by 14 water quality management agencies, including 4 of the largest POTWs in California, as well as the regulatory agencies that oversee them. So we're a neutral science organization that essentially works for both of them to provide a neutral scientific foundation for their water quality management. And one of the things that we're at right now is the precipice of how we go forward. I think the first question you're being asked is this model fundamentally sound? In other words, are we working with something that's useful here, or do we need to be going back to ground zero and reformulating how we do it? I think a second thing you're being asked to do is address the question of, okay, when we say 27% of the bite has a sublethal problem for 3 months of the year, is that 27% plus or minus 23% or plus or minus 2%, based upon the data that we are showing you, the validation work that Faisal showed you, or as in the written documents that he'll provide you. Where are we standing? Because we made a presentation to the State Water Board about a year ago. And one of the things that they said is, right now, we need to know how to move forward. The discharges said the same thing. We need to move forward with what are the next set of scenarios we run. Until we get feedback from you as to what we need to do to get the model in good enough shape to look at other scenarios, it's really not the right useful tool. Right now, we're running these kind of bookend scenarios. Remove 90% of the nutrients or remove none and see those huge changes. We need to be able to get down to much finer scale. So for instance, Dave Gibson, he is in charge of individual treatment plants and has to figure out what they should do. Right now, we're not running any models that say, I think, Faye, you asked this question before about where, you're better off if you're going to take that strategy, you're better off to do it at this facility or that facility, 50% here, 50% here, or 90% here and 0 here. Those are all things the model will eventually get to run, but only after we get the feedback from you about whether, in a sense, we're ready to move on. Lon mentioned, and one of the things that's part of a conversation that will take place is, are there alternative scenarios? Are we better off from a fiscal perspective to plant kelp and let it do its thing compared to a nutrient reduction? In other words, can you do these kinds of trade-offs? We don't want to start running those kinds of scenarios until we get feedback from you. Some of you asked questions, I think was about climate change and where does this fit? Actually, one of the questions a manager will ask is, okay, if this is what pH is doing, and then you do 100% nutrient reduction and you move it up to here, but then it just keeps going down, you haven't fixed the problem. You've bought yourself 5 years, 50 years, we don't know. The model would tell us what you bought. We're not running those things yet because we need the feedback from you about where we're at in the process. Do we have a fundamentally good model that allows us to do those kind of things? Or do we need to restructure? And then secondarily, what are the critical things we should improve to get us to the point that the model has a small enough window of uncertainty that we can answer that level of question? So I think that's along what you were asking me to kind of provide perspective on. And so what you all are providing us, I just kind of repeat, what Dave and Karen and what you all are providing us is really, how do we bring this community forward to get to that next level? So thank you.
Thank you both for that comment. Myself.
Oh, I'm so happy to hear that. Okay.
Thank you for hosting us yesterday. I think that's one of the highlights of coming this far. I have two impressions. Yesterday, I didn't smell anything, and I taste the water at the end. I think it's super impressive. That number stuck in my head, 180 million gallons come in, and then 130 million gallons of water and reused and pumped into the ground. I think this is showing the example, the willingness of the people, the willingness of the government, states, and the locals, and then of course you have the money to have that money behind it. I would just make one comment here. I talked to Martha and then Jim this morning. I understand this is all research projects. It's all science-based that you need to publish, and convince the reviewers, and then the model is reasonable to a certain degree. But when we come down to addressing specific management questions, I think we need to somehow bring in the engineering approach. That is really is different than you just publish it. And the engineering approach is a very specific set of goals and a different set of measurements, because what you do, it has consequences. There's hundreds of millions of dollars on the line. I hope we understand this too. I just want to make that sort of statement.
One thing I would like to follow up on that is, I think, Man, you mentioned that eventually, there's a possibility, right? This research model could be used in the future for operational purpose. I want to know, so maybe the charge for us is to, if we want to do that, what kind of improvement we need for this kind of model. But then imagine if the model is perfect, or it's not, it's never going to be perfect, but if the model is good for that purpose, what's the pathway? From your perspective, from the government perspective, what's the pathway to going there? I know NOAA has been doing this for a while. I guess Alex may be able to comment on that. They support scientific research, and eventually NOAA adopt the computational model either for numerical weather forecast or for coastal ocean forecast.
Right.
And then that serves everybody here, right? So I wonder, from your perspective, what's the pathway there?
Yeah, thank you so much for that question. I think, Martha, you'll be excited to hear my answer. I know Steve will. Because as you heard yesterday, the groundwater replenishment system didn't happen all at once. We didn't go to 130 all in one day or all in one chunk. We actually did it in 3 tranches. And this is not a quiz for those of you who walk through that corridor with a display, right? The first tranche recycled 100 million gallons of water to produce 70 million gallons of drinkable water. The second tranche, which happened a few years later, recycled enough to produce 100 million gallons. And then the third tranche produce 130, which just finished last year. The reason why I make that distinction is that the modeling, that work that we're doing now with SCORP, is looking back at the 70 million gallons per day increment, right, of water recycling versus the 100 versus the 130. And are those increments creating measurable differences in what we're studying? Because there are a lot of wastewater treatment facilities, like Karen said and Dave said, they're big and small POTWs that don't even discharge 30 million gallons. They're buried within that smallest increment that we work with. So if the model can shed light on the differences of these outcomes, these projections that we're looking into, doing a hindcast, as I think you would call it, right? Looking at the initial tranche of 70 million gallons of recycle, 100 million gallons recycle, 130. That's the kind of information that will help hopefully the likes of Karen and Dave to identify what constitutes adequate, what constitutes advanced, what constitutes necessary, if you will, right? In the different increments. We offer a real life example at OCCN and GWS to test drive the model at that gradient, if you will. So if you could consider your questions and your suggestions for model improvement based on this real life example, we have 70 years worth of data in our monitoring area to support this deeper dive. And I know, thank you, Steve, for agreeing to engage in that. I think it will shed a lot of light for our sister agencies on what to do for their system. Again, many of them are not even at 30 million gallons. We're huge by comparison. Hopefully that answers your question.
Yeah, so that's great example showing how we could potentially, the community can potentially use the model they're developing or they have developed. I guess my kind of follow-up question on that is, imagine the model is, the decision by water board or by you guys that is going to use the model to answer this kind of questions. What's the procedure? So are you going to just ask group in the future to answer this kind of question, or you want to build an independent organization or group, engineering group that just they are more the developers, and then the other group come in, adapt that system, like NOAA has these different groups, right?
Right.
They have people like Alex developing new models, but then the other group, operational group that taking what Alex developed, the perfect model Alex developed, and then
Are you available, Alex?
Right. So because that has implication.
Yes.
Right. Because the model is never going to be perfect. Even as Alex is not being perfect. All right. So this modeling group will be able to push the model to a certain degree, but eventually the operational group will come in. They still need to do some minor tweaks here and there.
Absolutely.
So where do the line should be drawn, right? So that if they're going to do that, then everything's on them. But if there's a separate group coming and do that, there is a line need to be drawn somewhere, right? So
as you probably picked up yesterday, based on our fabulous tour guide, we're an engineering heavy organization. For a biologist to jump in front of our board and all these engineers to say, this is what we're going to have to do to achieve compliance, that's a non-starter. We will have to engage the engineering team. And in fact, we talked a lot about dilution today. And with every cycle of the water reuse, we are taking away the purified water you drank yesterday is taken out of the ocean discharge, right? That drop of water is no longer going to the ocean, it's coming back for the water supply. But that also means that the behavior of our final effluent coming out of the outfall changes with a 70 million gallons a day tranche, 100 million gallons a day tranche, and 130. That requires engineering to redo the dilution modeling. And I think Scotty mentioned earlier that there is a very formalized process by the EPA when we design an outfall originally on how the dilution is determined. For a discharger like us, we must achieve worst case scenario when nothing else is happening around you're practically assuming still water around the outfall with our over 300 ports. You still have to achieve instantaneous and complete mixing. This is a bit of regulatory speak. But that's the assumption. And that's one of the asks of SCORP is to incorporate some of those engineering assumptions that were fundamental to our operation when we put that outfall together many years ago, right? And we designed our entire monitoring program around it. And this model can play very well with the originating model, but we must make sure there's alignment. Otherwise, we're going to be talking at cross purposes. We have to be aligned. And one of the things about your question is, where do we go from here? I believe, fact check me guys, I believe OCCN through our iterations of potable reuse, we've already removed nearly 50% of the nutrients from our ocean outfall. Thank you. Phew. It's a good team. But the model seems to suggest that may not be enough. That's a little scary for us because we're at 130 million gallons. I think these numbers were generated at 100 million gallons of recycle. So that's a little frightening for us, which is why that incremental differential, that delta between each one of those stages is really important to us, because for us, it's not whether or not we will take action, is how far do we have to go? And can the effect be measured where the supposed phenomenon is happening? It's really important for us to wrap our arms around the phenomenon that we're concerned about. It's absolutely critical. It can't be hypothetical.
I'd like to take a shot at it. So you asked basically the transition of the model into application. The way that we look at SWRP is probably very similar to the way that Alex operates. Our job is to build the initial tools, but not to be the group that runs it for everybody at all times. Our job is to transition the technology to our member agencies. Lon being one of our member agencies, Karen Mogus being one of our member agencies. So I'll give you an example of where this happens. We develop monitoring tools. For those of you who do beach water quality or are familiar with beach water quality, we were one of the leaders in the world in developing quantitative polymerase chain reactions, qPCR methodologies. We didn't want to set ourselves up to be the lab that does that for everybody. At the beginning, we did it side by side with them. So they got to the point that they could run it. And then it became theirs. And I think that's what will happen here. We'll build the model to the point that they can all run their own scenarios. Now, it may be expensive to do that, to maintain it. They may just say, you continue, but the idea is to get it into their hands so they can use it. I think the biggest challenge for us, and the reason I use the qPCR analogy, is that the modeling doesn't stop. In fact, all the things that you all are asking for, we're going to have a version control problem at some point in the future as we, as scientists, continue to work that. So with the qPCR example, 5 years after we trained them all on qPCR, we said, "Oh, we've got this new, better droplet digital PCR," and they go, "Oh, well, wait a minute, we just spent like all this money to get up to speed on qPCR. Now you want us to do something different." We're going to have that problem with the model. Where does essentially, how do we maintain a version control that allows them to know what they're using when and what's coming down the pike and how to make decisions based upon it? I think, you all are involved with those kind of things in other geographies, particularly Martin, I'm looking up at the screen now. You've been involved in Chesapeake Bay and you go through that kind of thing all the time. Any advice that you can give to us as a community? Because we are all working on this together. The state has funded some of the work. The utilities, I mean, you saw that monitoring data that we have, literally millions of dollars of monitoring. The fact that we have like all of this rate information, it just didn't come out of the blue. It came because they want to help us get the model right. They're all involved in this, but we've got to solve that problem of version control, and we'd love to get your feedback on that.
Can I just, Martha would probably want to respond. Anyway, I want to follow up another question, and then after that, I will promise I'll shut up. And the one, I guess it's more for probably both of you, that operational purpose. There are different meaning come with it. There could be just looking back at last 10 years or last 20 years, look at the impact and then make a decision based on that, hoping or assuming that the future will be similar, kind of have a similar reference level or changing a trend of change. But then could be like Noah's case, the real time. Right, so people are making predictions, or NOAA group make predictions of harmful algal bloom in Gulf of Maine in real time, and they make decisions on that. So I guess for you guys, is real-time prediction of this alpha impact is part of the long-term goal here as well, because that also has implication for the system they're working on. So
absolutely,
real-time data simulation.
Right.
So we have not talked about that, but if the real-time operation is a purpose.
That is a great question, because it goes to the how much and when, right? And if the seasonal phenomenon remains seasonal, do we really need to have a system that treats year round? Or if the seasonal phenomenon can be addressed with an in situ remedy that works year round, but has multiple benefits, such as establishment of a kelp forest or something of that nature to improve assimilation and removal of nitrogen from the system in part, and as long as we can measure the benefits, we can work on engineering solutions that's right-sized for the problem. But right now, what we're hearing is the problem has at times been described as something that's quite dramatic, like a dead zone or something like that. We don't think that's the case. We need to communicate the extent of the problem more accurately so we can affect solutions that are right-sized and effective through time. You know, if the solution is only going to address this issue for the next 10 years and then a volcanic eruption in Iceland overwhelms whatever it is we're doing, well, it's going to be a really difficult conversation for those of us who have to report to 2.6 million ratepayers to say, well, we're so sorry, we asked you to spend $200 million and it's gone. There will no longer be any effect. We're going to still do this, but the effect that we promise you has been overwhelmed by something else. Yeah. Does that answer your question?
Partially.
Partially. Okay, keep going. So, yeah, go ahead. Make sure, I just want to make sure I understand your question
I
correctly.
guess it's more about real time.
Real time, yeah.
This sleep modeling, if the goal, whether the goal, part of the goal
Right.
is to use this modeling tool.
Right.
To make a decision on
Right.
next season.
Gotcha.
How the outfall treatment
Right.
will be, this kind of.
I think if you look back at your tour yesterday, we're more like a aircraft carrier. We're not exactly a Zodiac. We don't move that fast. And when we,
I'm talking about longer term.
yeah, longer
It's not
term,
only for
right.
next 10 years, hoping for next 30 years or so.
Right.
Yeah.
Yeah, Martha, go for it.
Just kind of reflecting 5 years of community conversations where the operational sort of forecasting, real-time data simulation could be super useful is really an understanding, you know, what we're seeing out there right now, and even potentially assisting things like fisheries. And so I think that, you know, maybe the question is, should we take our model and operationalize it in order to really start to inform a lot of the, you know, these questions about climate change and what are we seeing out in the ocean today or next season? Or should we be relying on the WCOF's sort of effort, you know, the no operational models that are already trying to do some of that? So I think that that's a really great question. I think I want to help you out a little bit because I feel your pain in the sense that you guys are being asked to give recommendations without not necessarily really seeing all the edges of this. And so I feel like a reasonable recommendation for the management, for you to make of the management community, is that you ask them to create a strategic plan for what are the different types of applications they would like to see this model used for. Because then you can answer the question, well, if you want to use it for that, the where, when, how, kind of that type of sort of question, then you can really start to get much more specific about the ways that this model needs to perform, and even start to think about, all right, well, what are the performance criteria? So for example, if we turned off one source, Orange County Sand, or we just modeled Orange County Sand, then what are the ways in which we're interpreting that model output, and what are the limits to our interpretation where we shouldn't be allowed to go if we're only detecting 1 mole of oxygen change in the ocean, right? So I think somehow asking the management communities to start to develop a strategic plan for applications so that there's a clarity in what are the types of things you're expecting of the model would be really helpful, because then it would give you a launch pad for your recommendations.
Yeah, thanks, Martha. That actually touches on something I was starting to wonder about, because, you know, we're talking, I think we're all thinking in the direction of operational, because coastal ocean models, when they become applied to management and policy, usually go in the direction of detailed forecasting and daily operations and all these things. But I think the other analogy that maybe everyone, including the regulated community, might want to make for a model like this and the OAH problem is global climate models, where you use them. They have a concrete effect on policy and investment, but no one really expects that, you know, the engineering team building a wind turbine is going to run a global climate model themselves so that they can see the differential impacts of their turbine design. The application of the model is at a more strategic level than that, you know, decision support rather than operations or something like that. So I guess, you know, maybe I mean, I've noted Martha's recommendation of a management plan, but maybe Steve, maybe it's a question for you. Since you mentioned getting the model, the goal of getting it into the hands of the stakeholders, if you had any thoughts about that.
I think your thoughts are right on the money. I think that there is that difference, and I think the way people are talking about it right now is at the more strategic level. And I think as the model evolves, it will be used for making more specific management level decisions. But right now, until we kind of get the feedback from you all about, do we have a fundamentally good structure to the model? Do we have a reasonable level of assurance that the uncertainty is not too large to be useful? We're not ready to get to that next level. So that's why you all are so important to this process.
Thank you both for.
Thank you. Yeah, okay, next up, we have Stephanie Baker.
Thank you all. Thank you all for traveling and being here. And so my name is Stephanie Jager. I'm with the city of San Diego. I have more of an observational focus. So that's my background is more in observational oceanography and sensors. And I worked previously in Washington State, trying to answer some of these similar questions about the Salish Sea. And one thing I wanted to mention is that I remember reading lots of documents from SCORP and looking to the SCORP team for understanding things like biological impacts of changing conditions and modeling conditions, because I think that's something I really respect a lot of the work that they are doing, and especially around trying to understand actual biological impacts, because I think not all modeling teams are taking it to that level. So I just really respect all the work that they've been doing and all the effort that they put into this. So it's a lot of good work. So from my observational perspective, I'm out at sea. We collect observations. We have an ocean monitoring program where we do water quality measurements and benthic invertebrates. We do fish monitoring, as well as we do mooring program as well. And so I have a big part of the in the mooring data. So that's one of my focuses, because I have my interest is in that. Some of the initial validation work from this model in that 1997, 2000 runs, I think part of it was the limited data sets during that time, then as Faisal brought up. And one of the questions I think that I had earlier too was just about understanding the timescales of variability. And this is something you've brought up as well, time and spatial scales of variability. We will collect every quarter, we collect data across a 1 week period. And then so far that was compared to 1 month of model output. And as you know, there are transitional months like the spring, where those that can be a lot of variation. So my question kind of more revolves around just that the averaging, like comparing these really long periods, averaging model output, looking at averaging of observations. How may that impact kind of our model statistics or our assessment of model performance? And I'm really excited that Faisal kind of gave us a preview of looking at the time series data, and I hope to see more of that, because that's definitely something of interest to me. And we've had since 2017, we've had major improvements in the biogeochemical sensors that we put on moorings, both through the Del Mar mooring, through Scripps and other moorings that we operate as well. So I'd be interested to hear any panel recommendations too about if we can use data that maybe doesn't overlap with the modeling periods, but from that 2017 period to present, can that help us inform anything about the variability of the system, or how could we use that to make model comparisons? And this all comes from a place of just observing the conditions out there and seeing how they can change rapidly. So one of the, in the presentations, when we just see the chemical changes, things are happening in the ocean. So when you look at the range and some of the impacts that the model is predicting of control runs versus anthropogenic runs, we're looking at 5 millimoles of oxygen per meter cubed, which is the equivalent of about 0.2 milligram per liter at standard temperature and pressure. And so that's from my perspective as observational, oceanographer, it's a small change and it's difficult to measure. And we do see changes. We will see upwelled waters come onto the shelf off San Diego, and you could see, changes the oxygen by definitely more than 1 milligram per liter, 2 milligrams per liter. You see these large changes, environmental changes. So I think what would be helpful for me too is to see sort of a range of impact rather than just a single number. What would be a range? And then the other point I wanted to mention just was, so I've worked on, calculating aragonite saturation state, and you use pH data, you use total alkalinity data. There's errors associated with those measurements, just even creating the value of aragonite saturation state. There are error bars on the measurement, and then there's additional error bars with the model. So I think that's been the challenge for me, is trying to understand what are the ranges, what are the error bars in understanding the outputs. So, because if you just see an average single number, I feel it's not giving me the full understanding. And the information may be there, and I don't have that information yet. And then just to echo what Lon was saying too, just that we do know that water recycling is coming. We have plans for City of San Diego is going to be recycling water. About 50% out of the Point Loma plant that'll reduce nutrients. They're estimating around 20% as well through that process. And so I think that's where our interest really becomes peaked more in the plume dynamics, making sure that we're getting some of that mixing right, because we know we're going to do water recycling. And so just want to make sure that we have a good understanding of how that works in the model. And then thank you.
Thank you, Stephanie. Yep, any questions?
In your mooring data, I assume you have oxygen, pH, maybe nitrate sensors and chlorophyll, etc. I don't know the location, but say for your record of your data, have you seen the extreme hypoxia events? Have you seen the extremely low pH events? If so, how often, how intensive those events are?
No, great question. So we have moorings on the shelf near our ocean outfalls. So one's at 30 meters deep, another at 100 meters deep. Typically, there are short periods that we see in the spring and summer where we see low oxygen that gets up to especially to the 100-meter mooring on that shelf from the upwelled waters. Typically, the oxygen will decrease with depth, but we'll see this extra impact from upwelling. But on the other hand, places just north of us, so there's the Del Mar mooring, which is operated by Uwe Sen's group at Scripps, who we work with them for our moorings. And they see much even lower oxygen. They're more in the canyons. They're in the deeper areas. They have different circulation patterns. And so they will see these even lower oxygen events. I'll have to get back to you on the frequency and the time, but it's a great question.
I have a comment. I have talked to 3 field monitoring teams, and you guys, and Orange County field team, and also the LA monitoring team. So I'm so glad to see each region has their own people going out, measuring the potential impacts. And also I was talking to Karen, right? Over lunch about, so happy to hear that Karen is actually getting all the data from you guys and then so used for the model validation. So that's really great. I guess I just want to emphasize how important to share all this data, with Scripps, but also with the outer scientific community. And if we want to address this issue, then we have to work together. And sharing data is, it's a must. It's a necessary. And so, and getting people together, having the data in the same format, and simplify the procedure, and then automate the steps. That's really, if we want to move ahead, make the whole thing more efficient, and really trying to spend the investment or the effort on addressing the issue rather than looking at the issue, then that's really something we need to work together on.
So we had a really fun conversation with Faye during lunch about this sort of virtual twin concept where where, I think one of the barriers, honestly, to really having the community accept the model is just to give them the opportunity to take it for a test drive themselves. Right now, there's literally a queue outside Faith Bell's office of people waiting in line to get something from him. And so there's a pinch point of efficiency that's lost because there's a lot of expertise in what's going on in the ocean that's represented by all the monitoring community, and that, it would be great to have them drive around virtually and, inside of our model output and compare it with their observations. So I think, having you guys think carefully about some recommendations on data visualization or approaches that actually could encourage a more community approach to using the model output. Maybe that's one of the uses in a way. Maybe it's if they're in their reports, they're trying to interpret their own monitoring data, or even just trying to decide whether or not they really think their output is credible. That would be super useful to have some data visualization, even the virtual twin idea come to play so that they could really to take a community approach to that. So it's bi-directional.
Okay.
Right?
Yeah, thank you for pointing. Yeah,
anyway, I just thought I'd throw that in there because I think that there's a lot of merit. And we've been talking about doing that for a while, and it just hasn't come to the surface with respect to priorities yet.
Yeah, thank you for pointing out this two-way information exchange. I was more thinking about one way, but yeah, you're absolutely right. There, it could be to make it more efficient, it should be two-way. And then, so I guess that's also go back to on the earlier discussion about operational. So what kind of operational are we talking about? We're talking about real-time data delivery to the community stakeholders, or do we have to ask them to come to ask us, or we can make this information or tool available so they can just on their screen, on their phone, they can click on that. And then, so that's the whole digital twin thing that Faye and I, we went to a conference together. Faye organized a conference. I attended that whole digital twin idea. Then I think that's sort of a future that we'd like to see.
Well, I think it's for the panel to know right now is that from the time period in which we say, okay, we'd like to bring the model forward, let's just even say conservatively 2023 here, then it starts with, a collaborator in France running work. Then work has to drive, the Pacific Basin and or, 4 kilometer scale that gets downscaled. So there's multiple steps in how that happens, which is a significant lag, in my opinion. So I'd like to be able to compete with the operational real-time models, and there's no chance of that in essence of being able to do things that quickly. So we do the way that our modeling so I think it's not only BEC code that needs a bit of an update, our workflows need an update. If we're really going to be informative for the management community, we probably can't be running 5 years behind in our simulations, right? So that's something else you should be thinking about and just be aware of and think about what recommendations you would have to streamline our workflows if this is something that people would like us to be more in production mode on.
One question about that. In some regions, that kind of integration of models that get updated at whatever time lag they get updated at, observing data and so on, and then visualization and a nice web interface happens through the regional ocean observing systems, their portals. And we haven't really heard much about SCOOS. Is that a partner that you or some others in the room work with? Do they have a platform that you could see this melding into, or do you think that it would have to be constructed from scratch for this region?
Definitely collaborate with SCOOS. And yes, SCOOS is even has funded some pieces of this to try to actually start to get our model output online. And so I think that SCOOS is probably also reading the room in terms of management acceptance and making decisions about investments as well. And so I think it's at this point, whatever we do, we want to do it in partnership with SCOOS because we never want to replicate the amount of investment in data management than that's required. So we want to do this. In fact, the more partnership with NOAA and the oozes, the better, in my opinion. And I think that they would be happy to have coastal water quality community as a client for what they do. So it should be seamlessly integrated with SPOOs, and those relationships exist and we already enjoy them. We're just not sure exactly how to invest yet. I think that's probably the right way to say it.
Great, thank you, Martha and Stephanie. Maybe we should, do we have other commenters?
We have one last.
Okay, great, yeah.
So this time I think we're going to bring up Amber Bailey to Amber.
Thank you. I'll try to make it quick. My really comment is on the management process side. I come from the compliance with the EPA methods and understanding the role that SCORP plays in a development setting. And, one of the questions I thought when we were looking at, say, for instance, data qualifying methodologies, maybe out of step or maybe in a silo in the modeling side, was like, the range in the pH, a 0.4 plus or minus, right? And that is kind of qualifying some of the data. And that's interesting, but, from our side, we also have to operate in very strict manners for our pH, which we have a plus or minus 0.2. So we have very much, it's an intriguing question. And we were talking, Neil, about this application of management data into, or research into management and how we can help. And really that's what brought us here, is that, our board is part of a very sensitive community along the coast, very affluent, and wanted to know if we're causing a problem, how can we fix that problem, which been working with SCORP in that, how can we help fix when we see those issues. Those are also on the monitoring side as well. If there are other additional monitoring, as Dave Gibson had indicated as well, we certainly would be looking into that. But on this process side, it's so important for us. Our outfalls we have two outfalls. We have a 60 million gallon outfall and an 80 million gallon design outfall. And right now we're operating anywhere from 8 to 12 million gallons on each one of the outfalls. We've been recycling for the last 50 years. So when we make these broad assumptions about what's happening and people kind of hone in on what's happening at this large level, they don't really know that of 15 facilities, 2 of those facilities don't even discharge any longer in our outfalls. So I think this dynamic, and I appreciate this, the comments by Martha to get it a little bit closer to real time, because we've already made significant investments. So that point about data transfer from, the timing perspective is also, we have impoundment structures, we have to build pipelines, we go through SQL analysis, we have RFP public analysis. So it is really important for us to land on this idea of, when we talk about process flows, we need to really understand, what does that mean when we go into a, implementation phase? Is this 5 years? Is this 10 years? Because we're putting out our 10-year capital improvement project planning. So really trying to understand that. And then I'll just kind of close. It's something really important for us. And I know there was a comment in one of the slides earlier about the ROMS-BEC model is the only version they have. However, for us, we all have cell phones, and if you open your operating system on your cell phone, you know exactly what version you're on, even though the code that took to make it is updated all the time. You get a software update. So really, try to understand how we can, as managers, follow the ball on these development is so critically important to us, because like Lon mentioned, we have engineering, we come from an engineering world, and all of our engineers want to know exactly what we're doing. And so those details really matter. So understanding this, and I really appreciate the opportunity to comment and look forward to working with you all into the future. Thank you.
Great, thank you, Amber. Yeah. Yeah, don't go yet. Any comments, questions from Neil? Looks like you're ready.
That last analogy is a nice one. Is there in the engineering world, is there the professional way to do version numbers? Or would version numbers like in software actually be a good way to communicate?
I think because this is so software based, it is to me, this is a versioning of a system. That's why I kind of made the versioning of our, it's 0.24 is this. We all know when you develop software, there are versionings of these, and this is the alpha version or the beta version. What is it really ready for? And I think that type of standardized system will actually tell us where the model is, right? And I understand the questions of what you want to do with it, but in us, we still have kind of questions about the details. So like having a versioning system that can articulate on those sides, I think would really help our side to be able to better trust these ideas because like we've said, and we've met with Steve, we've had him at our office, we've met at Square. I mean, and the regional board, San Diego Regional Water Quality Control Board asked us to work with them. So this is why we did, you know, these codes. We have been working with them, sharing this information. So that versioning system is important. So I don't know exactly what that would be, and I'm sure we could find out, but and, you know, more articulate and documented changes over time.
It looks like Martha would like to.
Well, just that there's a really nice system sort of analogous to look at for any EPA approved inland water modeling. You know, EFDC, there's lots of different types, but there's a versioning system that's linked to a version of the model code. And if there's updates, you describe essentially what those are. And so I think that the precedent exists. The question is, you know, should we try to adopt something like that? And then, you know, what sort of documentation rolls along with it? I'm going to guess that the Chesapeake Bay program had to do something like this. They have ROMS, and then they also have the other management accepted versions. So Margie, you don't have to speak to this, but yet I feel like there's knowledge out there for how to do this. This is really solvable. This is pretty easy to address.
I completely agree on that. Margie, would you like, I don't know, you're involved in any of this version control thing? You have any experience on that?
Yeah. So there's one, and this is something that we, you know, they talk about all the time. And there's one regulatory model, and that is changed very seldom, so that it, you know, only once every, well, the very, you know, every several years or more. And that is the one that is used for regulatory decisions. And then in the background, all of this research is being done. So they do a major update, and then they switch over to the next version. And it's a little hard when you know your version that you're using for management is not the best version that you could do, but that's the way it kind of has to be for, you know, for their comfort level. So it's all documented. This is the version. And they have one model, and then they also have all these other models that give supporting evidence and help support the conclusions from the one regulatory model. But there's one regulatory model, and it's not updated very often. So anyway, I'll just add that.
So I guess this goes back to the discussion about operation, the definition of operation again. Right? Imagine if there is another team parallel to you, Scrub, that are doing all this engineering type of application to give information to Amber or to the stakeholders, and they will assume there could be in doing all this version control, and then every once in a while you guys develop a new module and then can be incorporated in that. So I think that's more like again probably Noah's model, but that's just my thinking on that.
Panel questions are then every time you do an app management update, do you have to go back and comprehensively revalidate and spend, you know, a significant amount of resources? So how do you think about that question? You know, we haven't encountered yet that problem, but I feel like that's a big one for us because it's a lot of work to do that validation. Or is that somehow part of our kind of core routine checks? Like, you know, so thinking about it from that perspective, no, it's not data assimilation modeling when we think about operational, but yet it still has to be really curated, everything that we're doing.
Yeah, and I think that's why the BEC program does do the evaluation every time they update it. So that's why it's not very often, because that's a lot of work.
Well, that's what I will say. I mean, the reason like we're talking about this as an issue is because version control, which is part of project management is not cheap, right? It does cost money, and people like from the no experience, like they have like army of people who just do like project management, right? So even like you may be like think like you are the lead of the research project, but you actually have the manager who just like manages flow, gate reviews, project version control, all of that, delivery of the data in a real-time data tanks. It's like if you ask one person to do all of that, will not move anywhere, right? And that line in front of your office will just grow, right? So any response to users request like, oh, can I look at surface fields, right? Can you give me like movie of, like most people actually who would ask those questions, they don't know how ROMS grid is set up. They don't know MATLAB sometimes, right? And you try to help everybody, and you just speaking from experience, same thing like with WCOS, we have like a real-time operational model. We also have like the research quality model that we have run like for 10 years, and we use it for scenarios. And a lot of users like asking like, oh, we have that ship that's off the coast of Washington on a seabed since 1941, and we may think that it will start, the fuel will start leaking, right? So we need a scenario. They don't know when, so don't need the real-time forecast model for that, but they need the model that can give them kind of, if it happens, what to expect. So, and you say, yeah, sure, go online, grab the outputs. First of all, we don't have those outputs online. You have to cut piece, give them the piece, and then it's like, oh, by the way, we don't know how to process it, what this ROMS grid is about, and you start helping, and it's like day after day after day. So what I probably want to say is like, when you say operational, there are two types of products, right? So we have the real-time forecasts. It's like a newspaper, and that's the news that's good, like for search and rescue, for instance, like environmental hazard response, like oil spills, but also those scenarios that you would provide is also like operational product. If you put it online, if you have resources to actually respond to the user's requests to run those scenarios, explain where the stuff goes, right? So operational products is not just a real-time model in my sense, right? So, and everything costs money to do, unfortunately.
And it's, you know, and then you also have the massive sort of technology readiness level. You know, and so I think again, I still ultimately think that a strategic plan for what we're trying to use the model for, and we're starting to sort of envision what are the applications, should be aligned against the performance criteria for the model, and then what are the other sort of pieces that are required to make it operational for use. Because I can tell you that as researchers, we're really bad at budgeting that part, you know, it's like really awful actually. So like being able to visualize at those different, you know, as you sort of evolve towards increasing management application, what are the components that need to be there to support community use? That's, I think that that's something that we're going to need to struggle with a little bit. Yeah. Any help that you guys can provide would be great.
Well, one of the good examples where it worked is this global Navy model that they would run, and they would give outputs nowcast to the public, and they would never have time or resources to rerun it from the very beginning. So we had like outputs available for 20 years, but they do provide version control. If you go online, you can read this whole version 3.9 kind of for this number of years, and there is actually a description of what they changed from version 3.8, right? And you know, like 2018, they would just go like from 30 layers to 40 layers, and they changed data assimilation scheme. That's it's all there, but it takes time and people and money to develop those types of tools. Yeah, so that's what kind of makes it the operational experience, not just like basic science.
Right.
So.
Thanks for those comments. Appreciate it.
Giving the time.
All right. Okay. Yeah. Thank you for the
Too much.
All right. Thank you, Amber, for the, yeah, that's great.
Thank you.
Yeah.
Well, I think what we've done essentially is I think what we've done here is we've kind of blown through two things. We wanted to get the public comments, but we also wanted to create a time for dialogue between the panel, the panelists, and the group at the end, and we wanted to contextualize that in some early comments or thoughts that you had. And so I don't think that we really need to. There's probably not a whole lot of questions left that you've had. I think we've done a pretty good job of plumbing the depths of the questions that came up, at least formally in the process over the last couple of days. And so maybe before we close and move into closed session, something that we try to do at end of our eyes is give the panelists an opportunity to speak to their just, you know, kind of just some initial thoughts that are important to them about and not speaking to any consensus of the group, but their thoughts and any closing comments you have for the group. I know, it can be tough, but they do appreciate the sensibilities that you have. And I know that means a lot to them to have the opportunity to hear from you. So, Mr. Chair, if you'd be so kind, I'd appreciate it if you guys have any closing perspectives to share with the group. Then we'll put here and online, and we share them now, and then we'll move into closed session.
Anybody volunteer? Any volunteers here? No? Okay, looks like
I don't know what's the, I think for the past day and a half, I have learned a lot. And I was talking to Masa and Steve. I think it was about 12 years ago. I was in Orange County when the West Coast Ocean Certification Program started. And I'm following this now. I'm glad to hear that modeling activities turn into the nutrient input from the land. This is not unique. This is the worldwide problems, the land-ocean connection. And then, there's a lot of phenomena associated with that, coastal eutrophication, the larger rivers and the fertilizer use. And then there's tremendous of the knowledge and the modeling capabilities have developed. And I certainly hope that your team will pay attention, not only for this piece of the ocean, but the worldwide. I think there's a lot of can be shared. And I'm pretty optimistic about really the new evolving ideas and then the interests and the potential resources. So we were talking about a marine-based CDR, and MCDR that has been over the place. Had the breakfast with Jim McWilliams this morning, growing carps, and then for very parts of the ocean, I think it's really come down to the proper marine spatial planning. And then not only to conserve and protect our ocean, but it's a proper use of the ocean space. I certainly hope with that in mind.
Can I say something? I don't hear any, I don't have any sound, but you can hear me?
Yes.
Okay. I saw some people looking at me. Sorry. I just wanted to, I guess, just as a brief comment, hopefully from me. I think there's a real danger in waiting to use information from models until the models are perfect or really, really well represent all the data that we have. The more data we have, the harder it is for the model to represent it all. And so I think it's, models are obviously never perfect. They're never going to match the data. And that doesn't necessarily mean that we can't use them for management. And that's kind of my underlying philosophy. We have to make sure they're good enough, and we have to continue and continue to improve them as we get more data. As the climate changes, our existing models may no longer work as well. So anyway, that's generally my philosophy is, I think we've, in science, there's been so much over the past decades, there's been so much uncertainty surrounding climate change. And there's been a failure to act in some cases because we don't know, and to use the resources that we have because we aren't sure what's going to happen. And so sure, there's a lot of uncertainties in the model, and hopefully we can identify some of those. But I don't think that's a reason not to use the model, and figuring out how, in which ways we can use the model. It's very difficult to get precise numbers from a model like this. But we can, it's much easier to give relative numbers. So relative, it's not very difficult to say whether, I would trust the model at this point in terms of, well, this wastewater treatment plant is going to have a bigger impact than this, or, this input here. So something relative, answers are much easier to get than this is going to be what's going to happen to, this, a specific number. So anyway, that's just kind of my general philosophy for what it's worth.
Thanks, Margie.
Well, I want to say thanks for sharing this development, and it's very interesting to see, very encouraging to see that kind of the best people in the field do this work using the best tools, and there's, for that reason, there is hope, and I hope they will stay in touch, and to like Northern National Ocean Service, where I'm working. So our kind of mandate is coastal prediction. Like I'm glad to see like California is not waiting until federals will do everything for you. So, and we will try to maybe pick up some. And there are a lot of questions that are similar to answer that you're asking about, like user engagement and visualization, quality control that we are facing these days. And I hope we can interact in the future and exchange ideas, right? And maybe hopefully one day no will accept the model and run the operations. So
Done.
Yeah, I just want to, I guess, say something on behalf of the panel that we, at least also myself, I think people on the panel will agree with me that we have learned a lot in the last 2 days, and also on the last, a few months that through the webinar, and we all, as oceanographers, I guess we're all oceanographers, we know how important the this issue is, right? The societal impact on the coastal ocean, and we're all trying to, we all have the good heart here, and we're trying to mitigate the potential impact to the ocean. And but a lot of times we just, we think that the big scale is out there, but we just don't have a direct sense of how big that skills are. And then through this discussion, through the tour yesterday, I personally really had a direct feeling of it or see it. So I really appreciate that. And also I appreciate all the hard work the modeling team had put into this, explaining what you guys have done, and also and addressing all the criticisms and also the suggestions, and also the steering committee, inviting us on this is a great opportunity for me to learn. And also everybody in the audience, and all the comments and the input, that's really it's really good for us, as a panel to know the scope of the stake, the scope, and as Martha said earlier, we're pushing the boundary of our knowledge here, and then trying to try our best to form or educated opinion, and then provide a recommendation and give that to the water board or to the steering committee. And then also appreciate the NWRI for the logistics and all the invitation, everything here. Yeah. So we'll try our best.
Thank you all. I appreciate the comments, and this has been an important couple of days. One thing that characterizes Southern California in a way that's different than any other place in the world is that no matter where you go, you run into people who work in, make their living in, surf in, fish in, swim on, ride their boats in, or sail their boats or kayak in the Pacific Ocean. It's probably the one thing that kind of distinguishes Southern California along with its weather from the rest of the world. So people love the ocean here. This is a really important thing. There's no way that California leads the world like it does in pretty much everything, and then doesn't have a model to help us know about water quality, right? It's obvious that we need to make an investment here. And I really appreciate, on behalf of the people that I represent here in Southern California, I really appreciate the 6 of you, Margie, thank you for all of you for deciding to kind of jump in this work. This is controversial work. There's a lot of different pieces, very complicated. Obviously, we're pushing the boundaries, and there's very smart people who are looking at every piece of this. And there are really important ramifications. And so we have a responsibility to each other and to the citizens that we serve, to do the best we can. And I think that your attention today, the group that's been assembled here today and for the last couple of days, I think have done a really good job. And before I close this meeting down, I think that I want to recognize the folks of the California Association of Sanitation Agencies. One of the things that was important about this is that we've kind of been talking about all days, is that it's interesting to think about the work you could do. Ultimately, you got to find somebody who can fund it and make it real. And in this case, it was a group of agencies at CASA that funded it and made it real. So before we go, I wanted to give them an opportunity to say thank you to you and make any other comments that they had. And then we're going to, I've got a few more remarks after Jared is done, and then we're going to retire to our closed session.
Thank you. just watching this over the last few days, this is exactly what we wanted to happen. Seeing the depth and caliber of the experts, the transparency of the modeling team to sit through an effective, like 7-hour deposition type of day, from the legal world, not an easy task, if maybe a dissertation defense type of thing. And having all the engagement from everyone here who traveled, our members contributed the funding for this. And towards that end, it's great to see the dialogues that have happened and the types of partnerships that kind of have been uncovered, where Lon Weiborg is talking about how they've shared data, or Stephanie Yeager is talking about mooring data that can be incorporated in. And I think it ultimately all goes back to our shared mission for protecting the environment. And that's what bringing us here together. And in the world of, scarce resources and finite funds, there's kind of ultimately the societal question of, if we need to fix the problem, what's that cost benefit trade-off? And what I've seen in my time in the water quality world and working with sanitation agencies, I think over 7 years now, our members are so committed to protecting the environment. They make that investment in the research, and as long as they're confident in the design of what's being asked, they will live with the results. And I assure you, across California water policy, it's not like that. But in our space, I'm so proud that we have that kind of commitment and fidelity to following where the science leads and doing the actions that need to be undertaken. So with all that said, I really hope we can assemble again in person at some time in the future. I know for being a layman and trying to track all this, a checklist could be really useful as a part of a report. So we could get some kind of schema of prioritization or low-hanging fruit and short-term, near-term, what needs to be done. I think I always envision additional model runs being performed after tweaks are done if needed. I don't know if that's actually the case, if they need to be, or if what's been done is sufficient for the questions asked. And that's what the report will address. But ultimately, I know there's commitment from our members to continue to support this. And I think seeing what we've seen over the last 2 days, they'll be there to continue to support it. So with that, I thank you to the modeling team. Thank you to the experts. Thank you for NWRI for fielding this. Thank you for everyone who's attended in person, being here, and for the ongoing work. The steering committee with the water board, I know working with Karen Mogus on this a lot recently, I'm just so happy for that collaboration too. And so we'll continue the dialogue. I know the state doesn't have a lot of money right now, may not have a lot of money going forward, and that's a whole separate kind of question we'll have to deal with. But that said, thank you, everyone.
Okay, we've reached that point where we're going to retire to closed session. The next steps that we're going to take are, internal to the development, and what we can get done today basically is get some talking points down and start the development of an interim report. What we're going to produce as a group, the panel is going to produce consensus findings and recommendations on the questions that are presented. Remember, we got those 3 questions. We're going to focus there. That's going to frame that's going to be the framework of the response. What you're going to see are the consensus findings and recommendations of the panel. If they can't gain consensus for their ideas, they're not going to find their way into our report. We're not going to have a minority report or alternatives, although there might be some alternatives if there's a consensus that alternatives are appropriate. So I can envision a process over the next 6 to 7 weeks as we're developing this report, where we might have a need for additional technical information to make sure that we are proceeding on a factual basis, and that we've got a full understanding as we're developing these consensus findings and recommendations. And then in the wake of that, once these consensus findings and recommendations take shape, that's where Mary and the NWRI staff really do their magic. They'll turn it into a report, put all the table of contents on it, put it in the right format, make sure that it's readable, it speaks to you in a single voice, and the things that are important to a reader's perspective. But we're not going to change the recommendations. I want to be very clear that the recommendations and findings that you see will be the consensus findings and recommendations of this expert panel on the questions that were presented. That's my commitment to you. I want to thank everybody for spending so much time over the last couple of days here with NWRI. We can't do our work, with one of the experts like, how many people work for NWRI? And the answer is 5 do. And we kind of like to think that we fight above our weight all the time. And but I couldn't do it without you and without Julie, who has not been here the last couple of days, but she's been sending us a lot of emails. So we're all working really hard to help this community, but we couldn't do it without the experts. We couldn't do it without the public entity employees. Thank you all so much. Let's take a break. What do you say we take a break, be able to say goodbye to one another, And then we'll continue, get back to work maybe a few minutes after 2 o'clock. Okay? Thank you so much. Bye, Margie.